All right. So I hope all of you are here already. So to those who are going to eat their lunch, so again, you can eat while listening or watching to our discussion. All right. So I hope all of you have already downloaded the Eagle CAD. Have you guys already downloaded and installed it on your computer?
Trial version lang sir kasi wala yung full version. Even, iba yung layout dun sa video mo sir compared dun sa site.
Really? Sa akin, di naman ako gumamit ng premium. All right. So mine is also, I think this is an education. Tingnan natin. So may tatlong kanya. I think this, the one that I'm using is for education or student version. So sa akin, Windows. So I just chose Windows and then I click download. And then, okay, so let's just wait. Still loading. Because I didn't also avail the premium one. The one that I'm using is the free version. I just sign up, okay, and then that's it. Okay, so as you guys can see on the upper right, I have my name in here. So I just sign up and then, yeah, it is now working as it is.
Yes sir. Pero I notice yours says education on the top, mine says free.
Really? Have you downloaded it on this website,
Yes sir.
www.autodesk.com?
Yes sir.
How about the others?
Free
What
din,
is the
sir.
version of EagleCAD that you guys have? Free then?
Yes, sir. Same then.
Is it also free? Because mine
Yes, sir.
is Eagle 9.6.2 education. Hmm. Well, this is not a cracked version. I also downloaded this one on their official website. So I don't know, but mine was downloaded and installed last year, I guess, or last year. So maybe there is a change, maybe.
Pero sir,
Not
I had
sure.
to apply for the education dun sa AutoCAD for
Uh,
to verify my account as a student, and it will take up to 48 hours pa daw.
oh, I see.
Because I only made my account
I don't
today.
know. Maybe well before last year, I guess, or last year, I just signed up and then it's working already. I didn't wait 5 minutes, 10 minutes. Anyway, so we'll see what we can do for today. Anyway, so this is just the start. So mostly are self-explanatory. So I have already uploaded, okay, the module 5. Okay, so please download this one now so that you can have your own copy. So intro to PCB and EagleCAD PDF. So this one is not yet finished. Okay, so there's still a lot actually. So as you guys can see, this one is 87 slides total for now. Okay, but this one is not yet finished. So it's still on the process. So I'm still finalizing some of the images or screen captures right here, so that we can have a uniform and single or a one way, okay, in routing things, in adding components, in adding libraries, etc., etc. Because we have a lot of video, or we have a lot of tutorials on the YouTube. Yes, all of them have one goal, but they have their own ways, okay, or different ways on, you know, creating their own schematic. Okay, so that's why I have this one, the step by step, so that we can have a uniform and one way of doing things. Okay. Anyway, so we'll go on with that one later. So supposedly, if you guys are going to take a look on our syllabus, we have here the introduction to circuit layout, okay, software tool, etc., etc., electronic packaging, wiring, and cabling diagrams. So before this week 5, actually, there is a, let's say, one meeting or two meetings before this week 5 that you should do a practice on how to use a driller, how to use a, what do you call that one? Anong tawag doon? Sa panghinang? Soldering iron. Yeah. So supposedly, okay, so I'll give you guys 1 week to practice on how to use this soldering iron, okay, because since our subject is laboratory, so you should have experienced it on actual. But since we are in on online distance learning, I won't be able to monitor or check if your ways of holding your soldering iron and then your lead is correct or no. But there's a lot of YouTube tutorials on how to use this one. Well, 3-minute video, 4-minute video will do just fine. The critical point is only tip. Okay, so the tip is the one that is always getting burned, okay, or it will what do you call this one? It will get destroyed or it will melt easily if you don't know how to use it properly. Okay, so yeah, that is the most tips that they will give you. So as you guys can see right here, we have the copper wire. So you should always have this one. So this is very important. If you have a soldering iron, you should have a copper wire and of course a stand. Okay. So the role of this copper wire is you should always wipe it. Okay. Upon, or let's say while you're using your soldering iron and then lead, right? So you should always wipe it with your copper wire. Okay. Do not let the lead stick on your soldering iron, especially in the tip, because it will melt or burn the tip of your soldering iron easily. Okay, so if you're not that careful, so it might only last 1 week. Then you have to buy another one again. Okay, so that's one thing that you guys have to experience. Okay. And one more thing, okay, so of course, if you have a soldering iron, then you should also have lead wire. Okay, so this is the one that you're going to melt to combine two wires or to connect a certain connection, say from wire to PCB or any connection that you wanted to connect on your circuitry. All right, so this is also one thing that you should also have if you want to practice using a soldering iron. And of course, a wire. Okay, where is that wire? So you should also have a cable wire. So any cable wire will do. But we have a gauge wherein it has a specific width or radius, let's say 5 millimeter, 3 millimeter. So they have their own usage. So the standard is, I guess, 0.05 or 1 millimeter, okay, thickness of the wire, okay, especially if it's going to use for practices like, this one, matrix board. Okay, so if you want to experience it on hand, then I encourage you guys to buy a matrix board. Okay, this one. So you can have a 4x4, 3x3, or even a bigger one, 7x9. So it's up to you. And yeah, just ask the electronic shop what is the recommendable gauge size for the uh, wires, okay, especially if it's for PCBs. Okay, and for the soldering irons, I guess this one is not that expensive. So you can buy a soldering iron with a stand as a bundle, I guess, as for, I don't know, maybe 350 or 450. So if I were you, if you have the money, so yeah, just buy it. Okay, though I won't be able to check it since we are in online distance learning. So this is for your own sake. So this is for your own learning or experience. Okay, so I encourage you guys to buy this one. Okay, so wires is super cheap, maybe 5 pesos per meter. So yeah, maybe just less than 500 pesos, then you can have a soldering iron, lead, and then a PCB matrix board. All right. So yeah, that is one thing that you will miss. Okay. So the next one is practice in drilling a PCB. Okay. This is actually already the last part. Okay. Let's say you have already created or made your PCB or printed circuit board. Okay, the official one using the Eagle CAD. Then it is now your job to drill the holes on your circuit layout. Okay, so what are those holes? So those are where you are going to put your resistors, capacitors, VCC, ground, etc., etc. So in other words, you have to drill for every pins of your components. All right. So this is also one thing that you will miss. Okay, but then again, if you have the money, okay, if you really want to experience how to do it, then let me know. Okay, so we can talk, or you can chat me from time to time if you want me to check your work, if you are really doing it right or no. Or if you want to do it on your own, you can search on YouTube. So there's a lot of videos there which can help you to, on how to use a driller properly. Okay. Anyway, this is call this one self-learning. Okay. Once you have uh, experience in using this one, then you will know what is the rightest way to do it. Okay. Well, my only tip is, just do it straight. Okay, because there are others wherein they are drilling it 45 degrees down, okay, or not that 90 degrees, okay, 45 or negative 45. Yeah, so those are the things that you will miss. Another thing is this one. So supposedly you will also, create some projects. So any project will do. So I will let you guys propose any breadboard project, okay, and then just show me, okay, that it works on actual, because the one that you're doing on the fritzing is yeah, super simple, and I know that most of them are working because most of them came from the internet. But in here, I would like you guys to create a project using the, some simple components that you can find on the electronic shop. Okay, like the others created a mini uh, sound system. So they bought a mini speaker. So the others created an alarm. So the others created on how to measure a water. What else? The others created, let's say, a burglar alarm, wherein if it's moved at least a little, so it has its sensitivity. then it will alarm, or the speaker will provide a sound. All right. So yeah, in total, I would say that this would take maybe at least 2 months. I mean, 2 weeks. Okay, including this one, the breadboard layout, soldering iron, experiencing on how to drill a PCB. And yeah, I guess those are the only things that you will miss aside from creating your schematic on EagleGet. All right, so are we clear with that one so far? Hello, are you guys still there?
Yes, sir.
Okay, so as you guys can see, once we're done with the Eagle Guide project, then yeah, that's it. So I highly encourage you guys to, do the things that I have mentioned. Okay, since we have a lot of free times to, experience a real PCB project. Okay, not just a virtual project. Okay, so this is the essence of a CpEDraft. All right. So do you guys have any other question before we proceed to our discussion?
None, sir.
None, sir.
Sir.
All right. So I also doubt that we will be able to finish this module 5 today. So I'll just cut it in half, maybe 1 to 40. Yeah, first 40 slides, then we'll stop right there and then we'll just continue the rest next meeting. Especially that this presentation is not yet finished. So even though we'll be able to finish this one, we won't be able to appreciate it since we are not on the printing part yet. So this is just choosing a PCB manufacturer. So we will actually skip this one because you are the one who's going to manufacture your own PCB. Okay. So of course you're going to print it and then you're going to etch it on the PCB itself. Anyway, so let us start now with our discussion. So for the module 5, so this is an intro to PCB and EagleCAD. So what is PCB? So you guys have already know this one. So you've been talking PCB many times already. So PCB stands for printed circuit board. Okay, so it is mechanically supports and electrically connects electrical or electronic components using conductive tracks, pads, and other features etched from one or more sheet layers of copper laminated onto and or between sheet layers. Okay, so if you're going to take a look on those, so we have coppers. Okay, we can also have aluminum or nickel, so depending on the metal that you're going to use. But mostly, we're using coppers for conductive tracks. Okay, so it's cheaper, it's a lot more effective, and it's better, okay, than the other metals. All right, so components are generally soldered onto the PCB to both electrically connect and mechanically fasten them to it. Okay, so printed circuit boards are used in all but the simplest electronic products. So this is one simple PCB. Okay, so we have here the front and then the back portion. Okay, so mostly we are designing our PCBs on the top side. Okay, and then if we can really route it, okay, on the top, then that's the time that we can route it on the bottom. So as you guys can see right here, this one line right here and then another line right here is on the bottom part of the PCB itself, okay, or the circuit board. All right, so in total you have printed two, so PCB on the top and then PCB on the bottom. So those two are different designs. All right, so before the PCB, okay, so we have this kind of wire wrapping on our electronics. So everything is connected by wires. So as you guys can see, this one is a little bit messy, okay, unlike right now it's much more beautiful. It's much more easier to understand and easier to troubleshoot. Okay, rather than with this one, that the conventional uh, PCB. All right, so here's an example of modern PCB. Okay, so we have here the connection. So I don't know what are those, but those are components that is etched on the PCB. Okay, and then the uh, orange or the copper that you are seeing right here are the copper wires, okay, or the copper, call this one, conductive tracks or paths of our PCB. Okay, and then some are already soldered, like this one. So this one is already soldered on the PCB, right? So here are some of the advantages of modern PCB. So of course, it's much more compact of size and saving of wires. So if you are familiar with our processors on our cell phones right now, smartphones, we have 7 nanometer, 5 nanometer, 10 nanometer, 12 nanometer. So as you guys can see, as time goes by, our let's say ICs, okay, ICs or PCBs are getting smaller and smaller and getting more powerful and powerful. Okay, so the smaller it is, of course, the more size that you can save, and then the more powerful that it can be. Because like you can double the performance if you can uh, shrink it into half. Okay, and let's say having the same size, of course, will double the performance. And ease of repair and diagnostic. Well, this one depends. Okay, so ease of repair is okay if it's a normal project, like simple or small project. But if it's a very high tech project or a high end project, like maybe the circuitry on our phones, like it's very, very hard to see the paths. Okay, where is this one connected, etc., etc. So you need a software or a mechanical thing for you to be able to check it. Okay, but in most cases, this one is a lot easier than having this one. Okay, so yeah, that's why it's much more easier to repair and diagnose. And saving of time, of course, it will save you more time since instead of doing this one manually, okay, like putting the wires from here to here and there, just print it, okay, and then the wirings are already done. So all you need to do is etch your components, and then yeah, that's it. And then immune to movement. So compared to this one, so some of the components can be moved easily, especially the wires. But in PCBs, so since our wires is already printed on the board itself, so we could say that it's immune to movement, right? So it's already fixed on our board. And we have here tight connections and short circuits are avoided, okay? So in here, this is very, uh, let's say, prompt to getting short circuited, especially if, let's say, a rat, okay? Say there's a rat inside of this uh, circuit board and then he ate some of your wires and that will cause a short circuit on some of your other components already. Unlike this one, okay, oops, here's our example. Like this one, so it won't be easily cut the line. Like for example, if we have here a damage, so we can still make a remedy on that one. Okay, but the one good thing, even though it has a damage on this part, it won't cause a short circuit since the line was just cut. Okay, it's not swinging. Okay, and there's no chance that it will touch the other lines. Okay, so that is why it's short circuits avoided, or it's not prone to short circuits, right? And of course, low electronic noise. So instead of having a physical wire, having a PCB or a printed line is of course much more lesser electronic noise. So we have here the explanation. So this leads to low radiation and pick up the electromagnetic waves, thus ensuring a lower crosstalk in between components and in between wire traces, which usually is a major concern in electronic circuits. Okay, and this one is also low cost since all you do is print it. Okay, and then you can already save a bunch of wires, right? And reliability. So all of the above mentioned are the factors that brings reliability in the performance of the circuit. Okay, so as you guys can see, we have a lot of uh, advantages, though it also have a disadvantage. Okay, so having a printed circuit board path rather, so it will only able to carry less current. Okay, so if your project is made for, let's say, carrying high currents, maybe 100 amperes, 1000 ampere, then PCBs are not made for that project. So you need a physical wire or connection on that one. Okay, because mostly if we have this small printed uh, connection, this can only carry, I guess, a maximum of 1 ampere to 10 ampere. So more than that will, you know, put your PCBs at risk. Okay, why? Because it will create heat. Okay, so the higher the current, the more heat that it will release, and then the more the heat that it will release, then the more that it's prone in getting destroyed, okay, or getting burned. That's why we are sometimes having some burned PCB, okay, like maybe the Samsung Samsung Galaxy phones before. Some of their units exploded, so maybe it's carrying too much current on their PCBs. Okay, so that is one possibility. All right, and so PCB cannot be used for heavy currents. And soldering needs precautions. So this should really be done by experts or someone who's really good in soldering things, because this is a double-edged sword. Like, yeah, soldering is one is okay, but uh, let's say you soldered it uh, improper, okay, or not proper, then it might cause the component to get burned and will not break. Okay, so you have to be careful in soldering some of your components, especially if it's IC. Okay, and yeah, so we have here types of printed circuit board. So we only have three actually. So we have the single-sided, double-sided, and then the multi-layer. But before that, I just would like to mention this one. So the creation of circuit pattern is accomplished using both additive and subtractive methods. So again, the conductive circuit is generally copper, and the other metals are aluminum, nickel, chrome, and other metals are sometimes used. Okay, so depends upon the spatial and density requirement, and the circuit complexity determines the type of board to be produced. So there are three basic variants of printed circuit boards, as below mentioned. So for super beginners like us, okay, so this is where we are going to start. So single-sided PCB. So if possible, only do a top mounting of PCB. Okay, avoid doing a double-sided because it will only complicate things. But if it's really needed to put the components on the bottom, then that's time that you can use double-sided PCB. Okay, so you have components on the top, and then you also have some components on the bottom. Okay, but if possible, if you can route everything on the top, then please do it. But if not, then you can do the double-sided PCB. All right. So they are self-explanatory. So single-sided is one surface only, and then double-sided are both sides. And for the multi-layers, of course, you have more than one PCB. Okay. So we have, let's say, 3 or more layers. So that's already a multi-layer PCB. So of course, we still have the top layer and then the bottom layer. And then the middle part is just, so you can have middle layer 1, mid layer 2, mid layer 3, and so on and so forth. So depending on how many layers you want to have. So this one is already super complex to create. Okay, so we will not be able to reach this part anymore. Okay, so we will only be able to reach this part, double-sided PCB. And then the rest are for professionals already, the one who's already, or the one who's really in the industry or the field of creating PCBs. All right. Okay, so before we proceed to the next one, do you guys have a question or clarification so far?
None, sir.
Sir.
All right. Okay, so we're almost done with PCBs. So we have here the layers overview. Okay, so in an official created silk screen, I mean PCB. Okay, so we have this silk screen, but mostly if it's just a PCB, okay, like this, okay, so we won't be able to reach that part anymore. Okay, for that is for normal PCBs only. So it's only up to the solder mask and copper. Okay, but upon creating the Eagle CAD, so it's optional. You can actually add a silk screen. So this silk screen is just the labels. Okay, so let me give you guys an example. Like for example, this one. So this is an example of silk screen. So we were able to put here the word lily pad. Okay, so it is created by putting a silk screen. Okay, so the importance of putting a silk screen is for us to be able to know the labels of your components. Like for example, right here, I don't know if you guys can see this one. We have here the off and on. Okay, so without silk screen, we won't be able to put those text or words. Okay, but mostly without silk screen will do just fine. So that's optional. But if you want to have a much more professional looking PCB, then add a silk screen. Okay. So how to add a silk screen? So you can add a silk screen coating on the Eagle CAD software. So if we'll reach that part, then I'll be able to show you. But I doubt that I'll be able to reach that part because it's on the last part already. So like for example, this one. Okay, so adding silk screen outcomes. So as you guys can see, we have here the ground, AO, A1, A2, A3, A4, A5, BCC. So those words, yeah, those words are created because of silk screen. Okay, or you can do this one because of silk screen. Though, again, it is optional. So it's okay if you will not put those words or text or labels. So just by having this kind PCB is okay. Okay, so both of them works the same. It's just that this one has a label. All right. Okay, so going back, and then of course we have here the solder mask, the copper, and then the substrate FR4. So to those who still don't know what is the middle part of the PCB, that one is actually a fiberglass. Okay, it's just that it has a different materials. That's why it doesn't seem like a fiberglass, but that one is a fiberglass. Okay, it's made out of fiber. All right, so we'll stop here for now, and then we'll just continue the rest on the part 2 and part 3. Okay, so goodbye for now, and see you guys on part 2.
Hello, sir.
Hello, sir.
All right,
No, sir.
okay. Hello. So to those who haven't eaten lunch yet, so again, you can eat while listening. Right. So let's continue now our discussion. So again, it only has three parts in total. So we have the solder mass, the copper, and then the substrate. Okay. So the solder mass here or the copper can be found on the top or the bottom. So if it's a double-sided PCB, then mostly it's on the top and bottom. But if it's a one-sided PCB only, mostly it's on the top side only. All right. Okay, so here are the parts of the PCB. So the first thing that you need to know is the FR4. So what is this FR4 stands for? So FR4 means, where is that one? Where is here? So FR means flame retardant. Okay. So this flame retardant or this word FR came from NEMA. Okay. So NEMA is the National Electrical Manufacturers Association. So we could say that this NEMA is the standard, or they've done uh, a checking or standard check with that fiber glass or fiber grade designation. Okay. Fiber glass reinforced epoxy laminate material, whatever it's that. But let's just say that it's fiberglass. Okay. So again, FR stands for flame retardant. Okay, and that's not denote that the material complies with the standard UL94B-0 unless testing is performed to UL94. Okay, so they have this kind of standard. So whatever it is, so the UL94V-0. So this one is the vertical flame testing. Okay, so this is one thing that you guys need to worry, okay, especially if you're going to create your own project. So make sure that it is a legitimate, okay, PCB, okay, because there are PCBs which easily burn, okay. Like for example, uh, I guess I wasn't able to include that one. Okay, so let's find that video. I just would like to show that if it's a super cheap PCB, it will easily burn. Let's see if I was able to add that one on the module overview. Simplex. I guess I wasn't able to add that one. Just different video, I guess. All right, since we are here already about flux, okay. So as you can see, this is just a simple copper wire. So he wanted to connect the red wire and then the black wire using a soldering iron and then a lead wire. So if you're going to take a look at this one, it doesn't want to stick on the copper. Okay, so that is where soldering flux comes in handy. Okay, so you can add this one. Okay, and then just melt it with the LED. Okay, LED wire, not LED. Sorry. Okay, so as you guys can see, it now holds the wire better than a while ago. Okay, so yeah, if you want to connect two wires, then this is where soldering flux comes in handy. So you might want to buy one just in case. Okay, so this is just a tip and tricks. And one more thing is if it cannot stick with your hole, okay, then you can also use the soldering flux to stick. Wait, so the person's distracting me. Okay, so while I'm speaking. So in here, as you guys can see, the PCB is a burn from the soldering iron. Okay, so if it's a original PCB or a high grade PCB, so you can easily remove that burn. Well, in fact, it didn't burn all through down to your PCB. Okay, so that is just a smudge wherein you can uh, apply some isopropyl alcohol and then just brush it, and then it will be gone. Okay, so that is one thing that you have to careful, especially if you're going to take a look on this one. You have a printed path in here, and if you burn that printed part, okay, then there's a chance that that printed path or copper will not work properly. Okay, so especially if it's a super cheap PCB. Okay, so yeah, just another advice, just in case you're going to buy a PCB. Anyway, if it's for practice purposes, then you can buy the cheapest one. Especially, uh, let's say you have the breadboard and then you want to connect it manually without printing it, okay, just by drilling it manually. So yeah, that one might come in handy. But if it's a printed circuit board like this, then you should level up the quality of your PCB. Okay, because this is where you are going to solder a lot of components. Okay. All right. So enough with that. That's just one thing that I want to mention when it comes to PCB. All right. So what else? So yeah, that's for the FR4. And here are some cheaper PCBs and perf boards. So this one is example of chipboards that is made from other materials such as epoxies or phenolics, which lack the durability of FR4. Okay, so I actually would like to say that if the color of the PCB is like this, then it's already made of epoxies and phenolics. But I don't have enough research. Okay, I don't have my enough information with me so that just ask the electronic owners if this is FR4 standard. Okay, so in here, it is saying that this one is the cheaper PCB, wherein it will easily burn the PCB itself, okay, upon soldering some components. Okay, you have already, and yeah, one more thing that you need to check. Yes, they said that if it has a bad smell, okay, upon soldering some of your components, then the PCB that you're using might be a cheaper or a cheap PCB, okay, which is not an FR4 PCB. Okay. So anyway, as time will go by, we'll be able to learn what is the best PCB for your project. Okay, so that is why I encourage you guys to buy your own PCB so you can uh, do a lot of simple projects. So just by lighting up a simple LED, okay, just by creating a simple speaker, just by having this kind of measuring circuitry, like it can measure sound waves, can measure water level, etc., etc. Okay, so you will know soon, okay, that the board that you're using is a good one or a bad one. All right, and here, so phenolics have a low thermal decomposition temperature, which causes them to delaminate, smoke, and char a little. Okay, so char means it will get burnt. Okay, so the one that we saw a while ago, the black one, so that is the definition of char. Okay, so hindi ito yung char na expression natin. Okay, so me myself have also searched what is the meaning of char. So I thought this one is short term for character, but it's not. So I would like you guys to search this one also. Char means like get burned or a blacky part on that let's say, burnt part. All right. And we have here the solder mask. Okay, so the solder mask is the topmost layer. Okay, the green one. So it is the coating of our copper. Okay, so actually you can remove the solder mask. So we have uh, uh, liquid components for it. I forgot the name, but yeah, you can deoxidize this one and then just reveal the copper one. Okay. So the purpose of this solder mask is to protect the copper, okay, whatever is on the bottom of it. So it could be a copper, it could be aluminum, or it could be chrome. So sometimes we have different kinds of metal below the solder mask. So it's not only copper, but mostly it's copper, but it's not limited to copper, all right? So this layer gives the PCBs its green, or at spark fan, it's red, okay? So this image right here is an image came from spark fan. Okay, so they put the color here red for the solder mask. Oops. Okay. So it is overlaid on to the copper layer to insulate the copper traces from accidental contact with other metal. Okay. That is one reason why we have the solder mask. Okay. Because if other electric or conductive metals touch the copper, then it will short the entire circuit. Okay, so that is the purpose of the solder mask, to protect it from scratches or from getting uh, shorted with other components or other PCBs. Okay, so this layer helps the user to solder the correct places and prevent solder jumpers. Right? And we have here the silk screen. So the white one that you're seeing is made by silk screen. So again, it doesn't do anything on our PCB. It's just that it is helping us to identify what is this component. Or in other words, silk screen is there for us to see the labels. Okay, so this is our guide, okay, for us to know what is this component, what is this path, where is this going? Is this a positive or the negative? Okay, so you'll be able to know the polarity of your PCB. All right. So yeah, that's it for the intro to PCB. Okay, so just 16 slides, and then the following 17 up to the 87 is already for the Eagle CAD. So before we proceed to the next one, do you guys have a question so far?
Wala pa naman, sir.
Wala rin, sir.
How about the others? Any question, guys, or clarifications? All right. So in here, you won't be able to appreciate this one. Okay. So you will not be able to appreciate this one if you don't have the Eagle CAD software yet. So may I know who are the people who doesn't have an Eagle CAD software on their laptop or desktop yet? So you can chat or raise your hand. So there's one. Who's that? I think that's Mr. Light. So Miss Santiago, Mr. Godfrey, Mr. Barasi, Mr. Golaitan, Mr. Dumagat. Ang dami nyo naman. Okay, so for now, okay, so tiisin nyo na lang muna. So just follow us, okay? Well, anyway, this one is self-explanatory. Since I put here this step-by-step on how to create a simple project, on how to import, on how to add, how to route, etc., etc. All right, so to those who have their Eagle CAD with their laptop or desktop, so I would like you guys to open your Eagle CAD now. and you will see this interface. So we call this one the control panel. All right. So are you guys here already? Nandito na ba kayo sa part na to? So once you're inside, once you're inside at the control panel, so I'll only mention two. Okay, so the libraries and then the projects. So for the libraries, this is where you can import some of the libraries or components that we cannot find on the EagleCAD by default. Okay, like in my case, I have imported a lot of libraries that came from SparkFun. Okay, so yeah, this is one way for you to add your libraries. Well, you can also do that one while you are inside of the project itself, while you're on the schematic. And then the next one is the projects. So of course, this is where you're going to create the folders for your project. So in my case, I have created two folders. So this is just for demos, sake of demo. So the first one is projects, and then the next one is new projects. Okay. Or you can just create, no. So I guess it's required. Okay. So it's necessary to put a folder. Okay. So just create a folder. So you can name it any name that you want. Okay. And then it will lead you here. So once you're done creating a new folder, okay, then you can now right click on that folder and then click new project. Okay, so in my case, I have already created this one, my first project. Okay, let me just delete this one. Gawa tayo ng bago. Alright, so I'll just create another one. So new project. And ano ba magandang pangalan? Project Eagle. So you can name it any name that you want, but in my case, I'll name it Project Eagle. Okay. So once you're done, then right click again that Project Eagle or whatever is the name of your project, and then click new or choose new and then choose schematic. And then this interface will pop out. All right. So in here, we are now on this part. I wasn't able to include the interface after clicking the schematic. Anyway, so once you're done with that, then you will see this schematic, okay, schematic layout. So in here, we call this interface or window as your schematic layout. Okay, so the other layout is called the board layout, but we'll move on another one once we're done with our schematic layout. So for now, we have to add some parts. Okay, so how to add a part? So in here, schematic design is a two-step process. So of course, the first one is schematic sheet, and then the next one is where is that one? It's lost. Anyway, so we have the schematic layout or schematic sheet, and then the board layout or board sheet. Okay, so of course you have to wire or connect first the components that you have on the schematic layout, and then you can now import it to the board layout. So in here, you can actually intermix those steps. So let me just show to you guys what is the board layout. So for example, for now, I'll just add some random components. Oops, not that. Logic gate. All right. So for example, I have a lot of components already. So if you want to switch, okay, on the board layout, then just click this one. Okay, on the upper left, we have this SCH and then BRD. Okay, and then it will ask you if you want to create a schematic if it's your first time to, have the board layout or the schematic layout. Then just click OK, and then it will lead you to this another interface. Okay, so this is another window called a board layout. All right. So in here, it will give you a blank canvas wherein, let's just say that this is your blank PCB. Okay. So in here, this is where you're going to put your components. So initially it's on the outside, and then you can now, put all of your components inside of this PCB. So mostly, if it can only cover this portion, you can resize this one, okay, into a smaller one. So why did I do this one? Because the smaller the PCB, the better. Okay, you don't want to have a very big PCB, but you only have 5 components in it. Okay, so you're wasting the size of your PCB already, or you're wasting your money. Okay, so again, the smaller, the better, right? So yeah, that's it for the board layout. So if you want to go back to the schematic layout, then you can click this SCH. Okay, and then it will lead you back in here. All right. So can you guys still follow? Hello?
Sir, how do I put that?
Can you guys still follow, guys?
How do I put that part there? Dun sa eagle. Yung red na yan.
Board layout.
Yeah.
Ano yan? Ito?
Yeah.
No,
Yes,
no.
sir.
This is just a random component. So you can add any component. Okay.
Yeah,
So this
sir.
is
How do
just
I
for
add?
the sake of demo. This one right here. So in my case, I don't usually use the tools in here, but mostly whatever is the name of that tool, okay, you can type it on this search bar in here. So just search add, then click enter, and then it will show, or this add component will pop up.
Okay, sige. Kita ko na, sir. Thanks.
All right. Okay. Well, the point here is you can intermix those steps. So you're not limited in, once you're done with the schematic layout. Okay, once you're done with the schematic layout, you cannot go back and edit your schematic layout once you're on the board layout. So you can do those at the same time. Like for example, you already have your board layout, but you still want to add another components. So add, say I want to add another. All right, so let's just say another one of this. And then let's say I want to connect this one. Okay, so in connecting components, use net. Okay, so do not get confused with this one. So we have line, and then we also have bus. But the one that we're going to use is net. Okay, not the bus, not the line. Okay, so it's always the net. So just click net or type here net. Okay, or if you want to use the shortcut, you can use Alt N. Okay, if you want to learn more about the shortcuts, you can go on the options and then assign. Okay, so in here, it will give you the shortcut key for the add, copy, delete, errors, ERC, run, window, etc., etc. Okay, so you can even add if you want a new. Okay, you can even add a new one, and then create your own shortcut. Okay, so in my case, I have only a modify one, okay, which is the window fit. So later on, I'll show on how to do the window fit because by default, it's not on our shortcuts. All right, so for now, let's wire things up. So there you go. Let's just say that this is also connected with each other. So whatever is your changes on the schematic layout will also change, or will also be updated rather, okay, on your board layout. So as you guys can see, we have another component here, and then they also have their own connections. All right. So as you are starting to add a component, you can already arrange them on the board layout. So to move it, so just click this move, or just type move, and then just look for this crosshair, okay, and then just left click that one, and then there you go. And then to zoom in and to zoom in and zoom out, so you can use your scroll, scroll of your mouse, scroll, how do you call that? Scroll bar. Okay, so you can
Scroll
use
wheel,
your
sir.
scroll bar, scroll wheel. So that's why it sounds weird. Anyway, so let's say you're already moving this thing, and then of course you want to rotate this one. So just click your right click, okay, and then you can now rotate that certain component, okay. And if you want to mirror, okay, just click your middle, or click your scroll wheel, okay. So in that case, you'll be able to mirror it, and then you can still rotate it. All right. Anyway, so yeah, that's it for the schematic and board layout. Okay, so again, in adding a component, just look for this icon, okay? Or you can type it on the search bar, add, okay, and then hit enter, and then will give you this interface. Okay, so I will delete everything for now, okay? So what I did is I grouped them, okay? So to undo, can add the same, it's Control Z. So just group them and then hit the delete button, and then you'll be able to delete that group or that component. All right, so the first thing that we need to do is add a parts, okay? So let's say we want to add LM555, okay? So let's do that one. So add a part, and then type here LM555. And then click OK. And then as you guys can see right here, it didn't show anything, okay? So the search bar on the adding a component doesn't work like Google, okay? Like it will give you the related components or related things, or anything, okay? Anything that is related with this keyword, okay? So in adding a component on the EagleCAD, you should put the literal, the exact name of that component. So you should know what is the exact name of that component. So well, memorizing the components will be very, very difficult, since we have thousands or even millions of components. So in that case, we can use wildcards, okay? So wildcards can be done by question mark, okay? So just add a question mark at the end, and then hit enter, and then it will give you any similar or related components with LM555. So in here, it showed one, which is under linear, and then 555, okay? And this is the reason why LM555 doesn't show up, because it lacks the letter D and N. So it has two types of LM555, okay? So if, let's say, the part or the component that you're looking for still not in here, then you can add another wildcard, okay, which is the asterisk. Okay, just add asterisk before the name of the component. So asterisk LM555 question mark, and then hit okay. Oops. No valid has been selected. Blueprints required. Okay, so if that didn't work, okay, so this is the last one, this which is the most recommendable. Okay, just add or just change that question mark into asterisk. So we have asterisk before and then asterisk after the name of that component. So just click OK. Why? What happened? Okay, let me just reset this one. So to reset it, just click this X right here. So it will clear the search text. Asterisk LM555 asterisk. All right, so for the keyword LM555, so still the same, but changing this one into asterisk will widen, okay, the variety of the keyword, okay, whatever is inside of that asterisk. So if you want to search for the 555, then it will give you many 555 components. So 555, 140, etc., etc. Okay, as long as it has a 555. So yeah, you can complete it at first and then lessen it, okay, just by removing the LM. If you're looking for a certain 555 component, then you can do that one. All right. So are we clear so far on how to search a certain component on the Eagle CAD?
Clear, sir.
All right. So one more thing that you guys need to know when it comes to searching some components, especially the resistors, capacitors, and inductors. So in here, we cannot actually, well, let's try RCL. So yeah, so the main category or the main name of the resistors, conductor, and capacitor is actually RCL. Okay, so RCL. So as you can see right here, I've used wildcard already, which is just looking for any name that has RCL, but it didn't show anything. So this is a different component. Okay, so I don't even know what is this component. So to look for the resistors, capacitors, and inductors, you have to look for it manually, right? So just X is one. Okay, just reset the search button, and then just look for the RCL manually. Okay, so right here. So it's RCL, and then just double click that one, and then it will give you this capacitor, inductor, and then resistor. Okay, and then inside of it, of course, there's more variations when it comes to CEU, CTRIM, CUS. Okay, so one thing that you can base, okay, if let's say you don't know what to choose, okay, this is a capacitor, this is also a capacitor, this is also a capacitor. All of them are actually capacitors. So we have a lot. So one thing that you can base with is the popularity. So in here, we have, upon clicking the specific component, it will give you the description. Okay, so it has a grid of 2.5 millimeter. It has an outline of 2.4 times 4.4 millimeter, etc., etc. Okay, so if you're looking for a certain components and then you're not sure which one to choose, then yeah, maybe you can read it first on the description part, or you can just simply base it on the popularity. Okay, so in that case, it will give you much more assurance that the component that you're using is compatible with the other components. Okay, well, in fact, any specific capacitor will do. Okay, so they are just simply a layout. Okay, it will not affect your or how your circuit works. Okay, it's just that it will give you this kind of layout. So it has 3 pins. This one has 2 pins. So one also has 2 pins, but different in dimensions. So this one is a little bit wider. This one is a little bit narrower, and also narrower, and then much more narrower. Okay, these come with different sizes. Okay, so that is one thing that you can also base with, and base it from its size itself. So this one has a 5 millimeter or 0.2 inch in size. All right. So yeah, that's how you add a capacitor, inductor, or resistor. All right. And yeah, all right. So once you're done with those thing, then the first thing that you need to do is add a frame. So in any project, you should always add a frame. So yeah, frame is not that critical component. Oops, sorry. Okay, so we don't have enough time anymore. So we'll just continue the rest on next meeting. All right. So I guess we now only have 10 seconds. So goodbye for now and see you guys on part 3.
Bye, sir.
Goodbye. All right, so while waiting for the others, so this is now your chance to ask a question. So any questions so far?
None, sir.
Yes, Mr. Dai.
Sir, pwede ba mag-test kung gumagana yung circuit dito sa Eagle? Hindi.
No. That's the reason why actually before proceeding to the Eagle CAD, you should do it first on the breadboard. Kaya nga dapat meron muna kayo ng manual schematic layout on the paper, and then do it on the breadboard. Okay, and then test it out if it's really working. Unless you can already imagine that it will work. Okay, if the volume per resistor is like this and like that, and so on and so forth.
Okay, sir. Thank you, sir.
So I'm not just sure, but I guess so 50-50. Meron kasing simulator na parang nakita ko dati. Fusion ba yun? But that's a different app, I guess. So I'll search more on other applications if we can simulate whatever is the one that we have designed on EOGAD. So I'll inform you guys if we can simulate it. Yan na po ba yung mga simulator natin? Yan. Maliban sa LT Spice. Well, LT Spice is just for checking the voltage output, current output, power output.
Yung Proteus, sir.
So
Proteus 8, sir.
Proteus is, yeah, I think Proteus is one application that you can create your schematic and then at the same time test it if it's really working or no, because you can use the Proteus to program your schematic with the use of Arduino. So very useful yung Proteus kapag connected siya sa mga ICs or sa mga abang tawag dito. Ano ba mga tawag doon? Atmel. Arduino, Raspberry,
microprocessors.
microcontroller. Yeah, microcontroller processors. But in here, just for ICs. I guess we don't have Arduino in here.
Microcontrollers. At meron.
At mga atme lang meron dito eh. Yeah, this is just an IC or microcontroller, but not the same with Arduino, wherein you can program it as it is. So this one is pre-programmed, I guess, like Mega 32. I'm not sure. I haven't used Mega 32 in my life, but maybe this one is also programmable. Anyway, so any other questions or concerns so far before we continue our tutorial on how to use EagleCAD? Questions or clarification? All right, so I guess there's no more question. Okay, so the first thing that you need to do, okay, upon having or starting your project, okay, so wala pa tayong nilalagay. So just add the frame for now, okay? So asterisk, frame, asterisk, okay? So by default, you already have this category frames. So you can put the letter L, okay? And then just click OK. But in my case, I will use the Spark Fan Aesthetics. And I will use the letter. So this frame letter is the same with this letter L. Okay. And put it on the bottom left of your schematic interface. So as you guys can see, I already hit the left click on my mouse and then already have my frame. But I can add another PCB frame, okay, or PCB design layout or schematic layout. So just click Escape to remove this one, okay, because we only need one. Then it will lead you back to the adding components. All right, so that's the first thing. And then just put it on the bottom left, and then hit Escape. And then step 2, okay, you have to save your well, this is just a reminder. You can save it after or once you're done with your schematic layout. But just in case, you know, it is a lot better if you will save your project from time to time. Okay, so this is one thing that you guys need to be careful. You guys need to be wary about is in saving your component in here is not done by Control S. Okay. So let's see what is a shortcut key for saving a component. Okay, so it's not even here. So that is why in saving a component, okay, well, I guess you can create a new one. I guess no. So it's not really possible to assign a shortcut key for saving. Okay, so to save this one, just hit this floppy disk. Okay, so you should do it manually. So from time to time, okay, just click this floppy disk. So upon clicking that one, it will give you this interface wherein it will ask you where do you want to save it and what is the name of that schematic layout. So I'll just name this one the same as the name of my project, which is Project Eagle. And it's under the folder projects. And then click save. So the same with the board layout. So just save this one from time to time. Okay. And for you to be able to check whether it's already saved or no, just go back on the control panel. So in here, you'll be able to see that you have the schematic layout. I mean, right here, schematic layout, and then the board layout. All right. You can even add a description if you want. So just click edit description, and then it will give you this interface wherein you can say here created at June, March 23, 2021. So you can even highlight it or bold a certain text. So, created by Daniel Troy Sabega. So this is the sample text that you will see. Okay, so you want to put this on the bottom or below this created at March 23. So put here paragraph. So there you go. And then what is this project all about? So just put here the description. Then click OK. Oops. Why is it not showing up properly? Well, in here, it's bold, okay? And it's on the other paragraph. What if it's bold only? Anyway, I guess that's a bug. Yeah, but you can add a description or anything that you want. All right, so let's now go back with the schematic. So now that you have the frame, you can now start adding some components. Okay, so let's just say that we will add these components. Okay, so we have here 0.5 millimeter barrel jack, okay, PTH, and then 0.1 microfarad ceramic capacitor. And then we have here a voltage supply and then a ground symbol. And then their quantities. Okay, and then the library where those components came from. So in here, we will import. Okay, we will import some library because by default you guys do not have or we do not have this SparkFun library, SparkFun connectors, SparkFun capacitors, SparkFun statics, etc., etc. Okay, so how to add or how to download a library? So just go to the component, okay, or add a part, and then open Library Manager. So I will just delete the SparkFun for now. So in my case, it's already in use since I have already downloaded it, but I will remove it for now. All right. So the first thing that you need to do is go to available. Okay. And it's still loading because it's still updating the library. So for you to be able to download a library, so of course you should have an internet. Okay. And then once you have already downloaded it, and then you can now work offline. So just wait maybe a minute, 30 seconds to 1 minute. So are you guys already on the Spark Library Manager?
Papunta pa lang, sir.
Okay. So again, just go to Component and then open Library Manager. And then go to Available. So there you go. So it says here, done loading libraries. And then just search for the Spark Fun. So as you guys can see, we have a lot of Spark Fun libraries. So we have Spark Fun aesthetics, Spark Fun batteries, capacitors, connectors, etc., etc. Okay, so we even have the others, which is word capacitors, burst connectors, word connectors, word components, word LEDs, etc., etc. So the one that we need to import or download is the SparkFun. So going back here, so we need the SparkFun connectors and then SparkFun capacitors, and lastly is SparkFun statics. So right here we have the SparkFun capacitor. So just click that library and then hit use. Okay, and then it will download that library, and then it will be imported to our default library. And then we also need SparkFun connectors. Just click use. And what else? SparkFun statics. And then just click use. All right. So have you guys already downloaded or imported those libraries?
Yes, sir.
So for you to be able to check if you have, if you've really downloaded it, or if it's really on your library already, so you can go to in use and then start looking for those libraries. So in here we have the SparkFun aesthetics, SparkFun capacitors, and then SparkFun connectors. So in my case, I have also already downloaded the SparkFun IC microcontroller and then SparkFun LED. But for now, just consider downloading this three for now. So we'll go over on those two later on. So once you're done with that, so just hit X, and then you can now go and search for the 5.5 millimeter barrel jack. Okay, so just take note that some of the description name of this component is not exactly the same. Okay, so maybe due to updates, because before we only have EagleCAD 6.0 or 7.0, but right now we have EagleCAD 9 point something. So as time goes by, maybe they've also updated some of the names or descriptions of that component. So in here, let's try to look for the 5.5 millimeter barrel jack. So go to components, and between this asterisk or wildcard, just type barrel jack and hit enter. And then it will lead you to this library, of course, SparkFun connector, since it's under this library. And then just click this power jack, and then it will give you many kinds of power jack. So in my case, I will just use the first one. Okay. Power jack PTH. And then just click OK. And then I'll put it on the upper left. Okay. And then hit escape. All right. So we now have the power jack in here. So have you guys already done this one? Do you already have the power jack?
Yes, sir.
How about the others? All right. So the next one here is capacitor, which also came from spark fan capacitors. So we need 0.1 microfarad. So under the add components, okay, I'll put here cap, just cap only capacitors, and hit enter. And then look for the library of spark fan. So here, spark fan capacitors. So I have here 0.1 microfarad. So I'll open this tab or this portion. And then I'll use, well, actually you can use any of these 5, but in my case, I'll just use the first one. Okay, so all of them are 0.1 microfarad. But in my case, I'll just use the first one. Then I'll put it right here. Right? So we only need one, so just hit escape. Then the next one is VCC and ground. So take note, yes, we have also downloaded or imported the library SparkFun Aesthetics. And if you're going to take a look the VCC, okay, so the SparkFun Aesthetics will not give us the VCC. Okay, so I don't know, maybe just some kind of error. So take note, this one, the tutorials that we are following right now came from SparkFun. Okay, so this is also their own library. So I'm not sure. Maybe they have removed the VCC and ground on the SparkFun Statics library. So in this case, we'll just use a generic VCC. Okay, so we can go to supply 1. Okay, and then have this VCC. All right, so just click OK, and then let's put it right here. So we only need 1, and then 2 ground. Okay, so in adding a ground, just change this VCC into GND, and then hit enter, and then go to supply 1, and then I will use this one, the second one, the GND. Okay, so you can use any of those. It's just that they have different symbols. But in my case, I'll just use this one. This one is much more simpler. Okay, click OK, and then we need 2. So left click, then hit escape. All right. So do you guys already have this kind of components, power jack, VCC, capacitor, and then 2 grounds? All right. Okay, so very good. The next one right here is adding a microprocessor and then other supporting circuitry. So we need at Mega 328P, 1/4 resistors, 5mm LEDs, 0.1 microfarad, and then VCC and then ground. So in here, we have to download the library SparkFun Digital IC and SparkFun resistors. So this is again another thing that you need to know. So SparkFun Digital IC is nowhere to be found on the available library. Okay, so what I did is I added or I imported a different components. So in my case, it's already in use. So the name of that one is SparkFun IC microcontroller. Okay, so I need you guys to use this one or download this SparkFun IC microcontroller. So it is the same. It is the same with the SparkFun Digital IC. So you can also find the Atmega 328P on the SparkFun's IC microcontroller. Done. So once you're done with that, just add also this one, SparkFun resistors. So import this one also. And then the last one is SparkFun LED. So you guys have to add that one also. So in total, we have added 3 libraries. So SparkFun, IC microcontroller, and SparkFun resistors, and then SparkFun LED. So in my case, I already have those on my library. So let me know once you have already imported those 3. Hello? So how was your progress, guys? Done? Okay, so
Done,
Mr.
sir.
Joshua is already done. Okay, very good. So once you're done importing those libraries, then you can now search for the components. So first is Atmega 328P. So between the asterisks, just type Atmega 328. And then it will lead you to the library SparkFun-IC-microcontroller. So in here, I will use the second one, Atmega 328P PDIP. Okay, then just click OK. So to pan, let's say you want to go on the side or right side or upper or bottom, just hold your scroll wheel. Okay, and then start panning. All right, zoom in to zoom out is also the scroll wheel. So I'll put the Atmega 328P at the middle. Okay, and then hit escape. And then the next one is 1/4 W resistors. So we need 4. So in this case, I'll just type here press and then hit enter. And then just look for SparkFun resistors. Where is that? SparkFun resistor. There you go. So in here, SparkFun resistors. So in here, you'll be able to find the, where is that one? 1/4 W resistors. So in this case, right here. So we have two 1/4 W. So we have 1/4 W 0.22 ohm and then 1/4 W 0.75 ohm. Since the description is, quite confusing, so we're not sure which one to choose. So I'll just go with 0.22 ohm. Okay, so 0.22 ohm, 0805-1/4 W, 1%. Just click OK. And then we need 4 of this. Okay. So the thing that I will do is I will rotate this resistor. So just hit right click, okay, and then left click. So 1, 2, and then 3. So 3 on that side, and then the other one is on the upper left of the microcontroller. Okay. So yeah, that's it. So 4 resistors.
Anong resistor ulit yun, sir?
So once you're done with that, yes. So 4 resistor. So 3 on the bottom right, and then 1 on the upper left of the microcontroller.
What kind of resistor
So,
ulit, sir?
1/4 W. Wait, balikan natin. So that one is 0.22 ohm dash 0805 dash 1/4 W, 1%. So were you guys able to find it?
Got it, sir.
Okay, so 3 on the bottom right and then 1 on the upper left. So just in case you have already put the 4 resistors on the bottom right, so you can move it. So just click this move and then look for the crosshair. And then once it's glowing, then you can now move it. Right? So the next one is 5mm LEDs. Okay, so it's under the library of SparkFun LED. So the name of that one is LED 5mm. So let's try to search the name of that one. LED 5mm. So there you go. So under SparkFun LED, open the category of LED and then LED 5mm. So just hit OK. And then we need 3 LEDs. So 1, 2, 3. So I put them on the upper portion of the resistors. Finish? So the name of that one is LED 5mm. All right, so how about the others? Sir Inigo is already done.
Finished.
Okay, Mr. Joshua is already done. Mr. Brian, Ms. Daryl. All right. The next one is adding a 0.1 capacitor. So as you guys can see, this 0.1 microfarad capacitor is the same with the last component we have added. So in that case, I'll just copy this one. Okay, I'll just copy this one. So just left click this copy right here and left click this component. And I'll put it, where's the proper position of this one? Okay, just here for now. There you go. All right. So just one capacitor. And then we have to add 2 VCC and then 4 grounds. So in this case, I'll just add and, or I'll just copy rather. So 2 VCC, I'll just copy this VCC. I'll put the other one right here and I'll just copy one more. And then the other one will be right here. And then we have to add 4 grounds. So again, I'll just copy, and then ground. So I'll put the ground on the bottom right. So one right here, copy again, another one right here, copy again, and then another one right here. And then for the last one, copy again, and then I'll put the other one right here. Okay, at the bottom left of our Atmel 328V. So are you guys already done?
Yes, sir.
All right. So the next thing, okay. So before we proceed to the next one, okay, let me just discuss this one shortly. So you guys keep on seeing this PTH, okay? So sometimes we also have NPTH. So PTH stands for plated through hole, okay, like this one, okay? Maybe like this one, okay? So it has a hole and then it's plated, okay? Well, this one is also plated, but the hole, okay, the one that is inside of this layer should be also covered with copper, okay? So that is why it's called through holes. It has copper all the way down, okay, connecting on the bottom portion of your PCB. And then we have the NPTH, which is, which is just a simple hole, okay, which doesn't have a plate or copper, okay? So the reason why we have NPTH is maybe this is where you screw, okay? This is where you put your screw for you to, put it on one position only. Okay, so that is its permanent position. While the others, so this is where you put the other components. Okay, that's why it has copper in it. All right. So what is the difference between making an NPTH or PTH for the PCB? So NPTH are drilled after the electroless copper process, while PTH are drilled before that. Okay, so that's how you create a PTH and NPTH. All right. So in step number 4, so you should have this kind of components. So just take note that I have missed. Okay, so this is my fault. So I have missed to include the grounds in here. Okay, so I have only included the 2 VCC, but I forgot to include the 4 grounds. So 1, 2, 3, and then another ground here, which I already have right now. All right. And for the step number 5 is adding the connectors. Okay, so in here we have to add a header, 8-pin header, and then a 2x3 header, 6-pin header, and then 2 VCC, and then 2 grounds. So yeah, since we don't have enough time anymore, so we will stop right here, and then we'll just continue the rest next meeting. Well, I encourage you guys to do this one on your own. So they are super self-explanatory. Okay, so after adding this one, then you will have those connectors or pins. And then you can now start wiring them, etc., etc. Right? So that's it for now. We'll just continue the rest next meeting. Right? This coming Friday.
Sige, sir.
You guys have a question so far? Question or clarification? Or any concern? None?
None, sir.
Great. So I expect that all of you already have the Eagle CAD on your desktop or laptop. So is there still anyone here who wasn't able to install the Eagle CAD? Could you please raise your hand or chat or chat box? All right, so I guess all of you have already installed the EagleCAD. So I'm expecting that you guys are on this part already, so that we can continue whatever we've left last meeting. So last meeting you wasn't actually able to, or I wasn't able to show on how to, you know, did I? Was I able? No. So I wasn't able to show that you need to add this one. Okay, so let's add this one right now. Okay, so again, we have to download some libraries if you don't have those libraries yet. So Spark and connectors. All right, so let's add a library. So again, add and then open library manager, Spark and connectors. Okay, so we already have it. So these are the libraries that we have imported, okay, from the available libraries right here. Okay, since we already have the library of Spark and connectors, so we can now search for the specific parts that we're looking for, like for example, M08 or M08, 1 times 08. Okay. So in my case, I'll just type, again, we need wildcards. So M08, so I guess M08 will do. And just click OK. And there you go. So we have here Spartan connectors and con 08 M08. So there are some updates. So the namings that we have in here are maybe the versions or the what's one past versions or the old versions that we have before. So the one that we have right now is the latest one. So there are some changes, especially in the namings. Okay, so before it's only M08, but right now the exact name of that one is BM08. There's now a B. Okay, so just get that one and then paste it or put it on the upper right of the microcontroller. Okay. All right, so are you guys already done with this one? So let me know once you guys are done so we can do it together at the same time.
Done, sir.
So who else? So who's here already done with this one? Please raise your hand or give me a thumbs up. Okay, so 1, 2. How about the others?
Nag-crash
Are
lang
you
yung
guys?
nag-crash yung Eagle CAD.
Ano yan?
Nag-crash yung Eagle CAD ko, sir. Teka lang.
Oh. Okay, so I will wait for you. So while waiting for Mr. Nico, how about the others? I have a total of 23 students, 23 participants. There's only 2 students who gave me a thumbs up. How about the others? The 20 students of mine. Saan kayo? Baka nasa labas kayo.
Sir, my question ako about dun sa model, yung NE555 timer na yun. Every time na i-click ko
Teka lang. Wala akong marinig. Okay, wait. Masyado yatang mahina yung sound.
Sound check. Sir, rinig na. Sir, dun sa question ko is yung NE555 timer. Bakit every time na i-click ko yan, biglang mag-crash yung application?
Sa LM555?
NE55 timer. Yung 555 timer na yun.
Anong tinatype mo sa wildcard? 555 lang?
Yes, sir.
555 and then look for linear. Okay, linear.
Yan, sir.
And then 555. So LM555D. Okay. Okay naman sa
Sir,
akin.
yan. Every time na i-click ko yun, biglang mag-shut down or close yung application.
Have you tried downloading the latest version? Kasi in my case, it's 9.6.2. What about yours? Baka may bug sa past versions din.
Sige, reinstall ko na lang, sir. Ano?
Kasi actually, I haven't opened my Eagle CAD for a year. And then I just decided to update this one. So upon opening this one, actually, it is telling me to update the Eagle CAD version. So before, I think this one is 8 point something or 7 point something, but right now it's 9 point something. So in that case, try to update all.
Sir, anong part yung in-import mo?
This one,
Yes, sir.
the library.
Yeah, what
Smartphone
part is it?
connectors. And
Okay.
M08. The name is, I've just type M08. So don't forget to use wildcards, okay? So M08.
Okay na, sir.
All right. How about the others? All right, so I guess the others are busy, maybe. Okay, anyway, so let's add another one, which is the AVR SPI PRG60TH. So let's try to find that one. AVR. So this type AVR. So add and then look for spark fan connectors. There you go. So we have 3x2 SPI property. This one. We are SPI PRG60. Okay. So in the case, it's 3 times 2 PTH. Okay. It's not 6 PTH. Because if you're going to look on the picture, okay, it is this one. Okay. So before, maybe the name of this one is 6. I don't know if you guys can see this one. This one is 6 in the past versions. This one 6 PTH. But right now, the latest update maybe change this one into 3 times 2 PTH. Okay. So just get that one and then paste it on the bottom left of the Atmel 3280. Okay, so let's delete this one since we don't need that LM555. Okay, so again, the name is EVR SPI Prog 3 times 2 PH. Okay, so Mr. Nico's already done. How about the others? Finish? All right, so let me know if you are still doing this one so that we can wait for you. If no one will speak, then we'll just proceed to the next one. Ano yan, Mr. McFly?
Sir, tapos na po.
So, dalawa pa lang kayo ni Mr. Inigo na na-confirm ko. Okay, so I hope the others are also done in doing this one. Okay, so the next one is 16 serial programming header. So the exact name of this one is Arduino serial program page. So let's find that one. So I'll just type Arduino. Let's see. SparkFun connectors. So I think it is this one. Yeah. So the name of that one right now is 16 serial cable PPH. Okay. So if you're going to take a look on the description, so also known as Arduino serial program header. So maybe before the name of this one is Arduino serial program PPH, but right now the exact name of this one is 16 serial cable PPH. Okay, so they maybe updated this one. Okay, so just click that one and then paste it on the side. Okay, on the left side of the Atmel 3 to 8. Finish. Okay. Okay, so dalawa lang kayong kuan. Masabay. Alright, so Mr. Dai is also doing it. So that's a good thing. Tatlo na kayo. Okay, so 5 pala. Nasa 5 na or 6. Okay, Mr. Darwin and Mr. Louis Azriel is also giving a thumbs up. Okay, it's good. So at least mga 6 or 7 na yata kayo. Okay. It's also good thing, Mr. Carino. Okay, next one is a VCC and ground. So we need 2 VCC and 2 ground. So again, before we cannot find it on the SparkFun statics. So we'll just look for a generic VCC. Okay, that whatever is we have on the default library of the Eagle Guide. So just remember. So instead of going and look for a VCC and ground. So since we already have some VCCs right here and then some ground, we'll just copy this one. Okay. So copy and paste it one on the side, and then another VCC will be on the side. Okay. So that's a total of 2. Another one is right here. One right here below the AVRSPI prog 3 times 2 PH. And where is the other one? See? 1, 2, 3. There you go. So another ground right here. All right. So let me know once you guys are done.
Sorry, sir. Anong part ulit yun?
VCC and ground. Okay. You can just simply copy one of this and then paste it one right here for the VCC and then another one right here for the VCC. And then
Okay, got it.
we need 2 grounds. So one ground here and then another ground right here below the AVRS. Yeah. Okay. So Mr. Nick is right done. Okay, Mr. Brian is also finished. Okay, Mr. Louis, Mr. Joshua, Mr. Mark Bernal, Mr. JD, very good. Okay, So most of you are already done. So the next one, oops. The next one, so your schematic layout should be look something like this. So as you guys can see, I missed the 3 grounds in here, so I wasn't able to add the 3 grounds in here. So that is why I've mentioned here that add 3 more grounds right here. But anyway, you guys already have it, so no problem. Okay, so the next thing that we'll do is we will wire them. Okay, the correct term is actually wire, but we will not use the wire tool in here. Instead, we will use net. Okay, so we will net them all together. Okay, so again, do not use wire. Okay, in our latest version, this wire is actually name line right now. So we don't have name wire in our tools right now. So we only have the line. So if you're going to take a look on this one, we have here the line. So before this one is wire, but maybe I updated this one into line. So the one that we're going to use is net. Okay, so you can start to explore that one now. Okay, so all you need to do is click net. Okay, or in my case, I always use Alt N. Okay, Alt N is a shortcut for net. Okay, and then we will try to follow this kind of layout or schematic. So we have the VCC and then followed by the capacitor down below. So I'll just move this one a little. Move. Okay. There you go. And connection right here, ground. And then I will also move the ground, this ground right here down below the capacitor. And then this ground right here. Maybe this is sweet. Okay, there you go. And we will now start to net them. Or you can click Alt N. Okay. So just left click, okay, and then hover it and then look for the specific points where you want to connect them. Okay. There you go. So you should have something like this. Okay, so Mr. Nig is already done. Okay, so Mr. Joshua is also done. And Mr. Charles is also done. Mr. JB, Mr. Daif, very good, very good. Mr. Puwa, Mr. Kagiwa, Miss Santiago, okay, very good. All right, so it seems that most of you are already done. So let's now proceed to the next one. Okay, so one more thing that you need to know is this one is an indicator that this is a junction. So it's a point where there is another component connected side by side or on the other side. Okay, so let's just say that this one is already connected to this one. So this is an indicator that they are already connected with each other. So if you will not see any junction like this, meaning they were not officially combined. So all you need to do is check, okay, zoom in if they are really connected with each other. Okay, so it should be something like this. Okay, the same with this one. Okay, so just zoom in to check if they are, or if your wire is really connected. All right. Okay, so the next one right here is we'll route the Atmega 3 supporting circuit 3, which is something like this, and this one right here. So first, we'll start on the upper left of the microcontroller. So right here, there, and then there. All right. So we have the resistance on the second. Okay, okay, so Alt N right here, right there, and my bad. So that is not the correct connection. So AVCC and VCC. And then for the reset, it is the one that is connected on the resistance and VCC. And as you guys can see right here, this capacitor needs to be flipped, not really flip, rotate. Okay, so just hit right click. Okay, right click of your mouse, and then put it horizontally, and net this one together. There we go. Okay, so copy this one as a test. So once you're done, just give me a thumbs up. So to erase a connection, just use delete. I guess the shortcut of this one is Control D. So Control D or click this trash bin right here, and then click that component. Okay. Welcome, Mr. Kuba. Okay, Mr. Joshua is already done. Okay, Mr. Kuba, Mr. Mitlay. Okay, Mr. Daet. All right. So the next one is we will connect this one on our microcontroller. Okay. So if you're going to take a look on this one, guys. So you see that this one is flipped or mirrored. Okay. And then the number one is on the upper right. I mean upper left. Okay. But in our case, it is on the bottom. Okay, and number one is on the right side. So it should be on the left side upper left. Okay. So what we need to do is we need to rotate this one. So right click and place it like that. Okay. So I'll just align this one. So number two should be aligned with your number 23. Okay. Because number two will be connected to 23 and 3 is 24, 4 is 25 until 7 that is connected to 28. So number 1 is connected to BCC and then number 8 is connected to ground. All right. So net or alt N. Okay. There you go. So one thing also that confirms that you are trying to connect or you're trying to net a connection, let's say this one, is there will be a green around that green circle. Okay, so it's an indicator that you're trying to connect a net in here. So the same on the part where you're going to connect it to. So there's an indicator that you wanted to connect it right there. Okay, so number 2 will be connected on the 23, 3 will be connected on 24, 4 will be connected on 25, 5 will be connected on 26, 6 is connected to 27, and then 7 is the 23. All right. Finish? Okay, Mr. Abisu and Mr. Joshua is already finished. And Mr. Doman also, Mr. Nikolai, okay. And Mr. Louis, and Mr. Charles, and then Mr. Bisanyo, and Ms. Santiago. Okay, very good. So the next one will be the bottom right. Okay, this one. So we have the connection of D1 to 15, 16 rather, and D2 is to 15, and then D3 is to 14. Okay, so let's do that one. So 16 is connected to D1 up to its ground, and 15 is connected to D2, and 14 is connected to D3. There you go. So see, you will see a junction wherein this is an indicator that this one is connected to this pin. Again, this component is connected to this component. And then another one, this component is connected to this component. Okay, so there will be always a junction when two components are connected with each other. So that's an indicator that they are connected with each other. But if it's a pin to pin, okay, so this is not actually a official component. So it's just a pin wherein maybe you're going to connect here some wires, okay, right here. So yeah, this is just basically a wire, okay, wherein maybe you're going to drill this part, and then this is where you're going to put the ABC 0, ABC 1, ABC 2, or this will be inputs that will be coming from other electrical circuit. So that's the role of our pins. Okay, so are you guys already done? So once you're done with this one, then you may now also connect the 22 and 8 to our ground. Okay. 22 and 8 will be connected to our ground. So as you guys can see, the pin 28, 22 and pin 8 is both ground. So we have to connect those two. And then the voltage source of this one is connected to our VCC, the same with a VCC. Finish? Okay, Mr. Kuwa is already done. Okay, Mr. Joshua, Mr. Dait, Mr. Niklai. All right, so the next one, so or we'll get it done with this part. Okay, and then, okay, so in here, making name labeled net stubs, we call this one net stubs, wherein we have a floating connection. We will do this one because we don't want a messy, okay, or an ugly schematic layout. So if you're going to take a look on this one, guys, so look for name on the tools that we have right here. So click that one, and then click our wires. So they have namings, wherein this one is NS2, this one is VCC, this one is ground. Okay, so they have their own address. So basically, we want to connect the ground. Okay, no, we want to connect the CTS to, is it? Okay, like this one now. Okay, I'm not sure where to connect CTS and VCC for now, but TXO, let's say we want to connect TXO to our microcontroller RXT. Okay, and we want to connect the RXI to the microcontroller TXD. Okay, so if you will do that one, well, you can do that one by routing a very long wire here. So you're going to route it right here, going right here, and then connect it right there. Okay, but we don't want a massive connection. So instead of doing that one, we will just use a floating line or net stub. Okay. So the first thing that you need to do is leave this one or make or create or put a floating net, okay, on that specific pin or specific connection. Okay, so we need 6 of them. 1, 2, 3, 4. Yeah. So all of them. So we call those net stubs. And then once you're done with this one, so we have to name that specific wire or the specific net. Okay. So our goal in here is we should have the same naming on this floating line on to any pin where you want to connect it. Okay. So click name and then let's name it G and D. Okay, and then just hit yes. So this is a warning that you're trying to change the name of this wire from NS1 to ground. Okay, and then just place it right here. And then this CPS is still CPS, BCC is still BCC. But for the TXO, okay, so take note on this one, the TXO, the name of that one will be RX. Okay, because we want to connect the TXO to RX on the Atmel 328P. And the RXI will be connected to TX. Okay, so this T and R is like our receiver or transmuter, okay, or the sender and receiver, in other words. Okay, so we want to send from TXO, and then it will be received by our Atmel 3 to 8P. So vice versa. So we're going to transmit from 3 to 8P, Atmel 3 to 8P, and then it will be received by our receiver on the screen. Okay. So in here, the name of this one is CPS. And VCC is still VCC. And TXO is RX. I'm not mistaken, RX. And the RXI is TX. And DPR is still DPR. All right, so just do this one for now. All right, so we don't have enough time anymore since we're only limited for 40 minutes. So I guess we only have 30 seconds. So we'll just continue the rest on the part 2. Okay, so goodbye for now and see you guys on part 2. So just do this one for now, okay? Click name and then name them gram CTS, etc., etc. Okay, so goodbye and see you guys later. While we're waiting for them, do this one for now. So while waiting, do you guys have a question so far or clarification?
Sir, regarding the project, yung final project po, sir, kailangan mo ng board, schematics, yun ba, sir?
Parang ganun na nga. So actually, the only hard part in your final project is maybe the final board layout. Kasi yun talaga yung pinaka-i-check ko. But of course, I need the, actually kailangan pa sana ng paper. I need the schematic layout, the block diagram. And ano pa ba mga kailangan? Maybe the flow chart also, how it works. Okay, so that depends. Hindi ko pa alam kung ano pa yung mga ipaparecord ko. But most of the topics that we have finished. Okay, so it is a combination. So it's one system, but it has a block diagram, it has a flow chart, it has a schematic diagram, and it has the actual okay, layout in breadboard using FreeSync. Okay, and then finally, just the board layout. Okay, so creating schematic layout on EagleCAD is super easy. However, in schematic or board layout, this is the most difficult part. Okay, so this is mostly where I will check your final project. Okay.
Sir, can I use the
So,
last circuit na ginawa namin nung embed lab?
Hindi pa. Hindi ko pa alam. Kasi we're going to have a proposal. Okay. So I'll post it later on. Okay, or maybe next week. So we're going to have a proposal. We're going to propose a project. Okay, so that will be the official project that we're going to create up to the finals. Okay, so we are going to have an exam. Okay, but mostly para kasing pinapa-required lang sa amin na kailangan ng written final exam. Okay. Pero mostly yung ibibigay ko doon is nagawa nyo na actually. Or ginagawa nyo na sa ngayon pa lang or next week gagawin nyo na. Okay? So I need you guys to submit the block diagram, the flow chart, schematic diagram, etc. etc. Okay? So you're going to submit a file. Okay? You're not going to answer anything. Well, if you're going to answer anything, maybe it's an essay, okay, on how your program works. So it's not multiple choice. It's not competition or anything. Okay? So you're just going to submit your final project. So that will serve as your final exam. Okay? So yun lang naman.
Sir, walang written? Yun ba yung narinig ko? Walang written exam?
Wala nang written.
Meron.
Kung if ever there will be a written, that will be an essay. Okay? In a way that you are explaining your system or your final project, how it works, what is the purpose of that one, etc. etc.
Okay, sir. Salamat.
Okay, since this is laboratory, supposedly hindi ako bibigay ng mga written. But we are actually required kasi. So, yeah, that is one reason why we need to put a final exam paper na nakikita nila. Hindi lang yung bastang project. Anyway, so are you guys done with this one? Okay, so tapos na kayo? Tapos na? Okay, Mr. Joshua is already finished. Alright, so I hope the others were also done. Okay, so nasa slide 42 pa lang tayo. Okay, anyway, ang importante, nagagawa nyo siya little by little. So I just noticed one thing a while ago. So the warning that you saw is meaning there is already the same name that you are trying to put in there. So meaning you're trying to connect this pin on the ground, okay? Like for example, right here, we have a name ground right here. So basically this ground right here is also connected with this ground right here. So yeah, yun yung mga floating lines natin. It's just that hindi sila connected physically on the schematic, but in the board layout, they are actually connected. Okay, we only have one line of connections. The same with our VCCs. So this is connected with our main VCC right here on the power jack. Okay, so it has a name of VCC. This one also has a name of VCC. So basically, this is connected right here. This is connected right here. This one also right here is connected right here. Ano pa ba yung VCC natin? Okay, we'll be having one more VCC right here, I guess. And this one right here will be connected in this way. It's just that we're using net stub, so we call that net stub, our floating line, wherein just to avoid having a messy schematic layout. We don't want to have a, uh, like the spider web, okay, schematic layout. We want to make it as simple as possible. Hey, so the next thing that we need to do is create a net stub on this side on the upper left of the microcontroller, and then a net stub also for the number 2 and 3. So name it BTR for this one, and then name the number 2 for RX, and then name the number 3 for TX. Okay, so let's do that one. So the first thing that you need to do is create a routing line. Okay, and then this bar is connected to BTR. Just name it BTR. And there you go. We have a warning again saying that, are you sure that this line will be connected to the previous DDR connection? So just say yes. There you go. So in other words, this one right here is connected with our DDR right here. Nag-pop up yung mic mo. Wait, let me check. Headset, speaker. Okay. So is it okay now? Still no. Yeah. It is the keyboard because I'm using a mechanical keyboard. Maybe. Okay. So, kaka-alt-tab ko siguro yan. No? Nag-alt-tab ako ngayon. Yun. So, maybe yun nga yun. Alright. How about now? I'm not doing anything. I'm just... yung mic. Really? Tinutopak ulit siya. So, I will not use this one anymore. Hello, mic test. How about now? Can you guys hear me?
Yes.
Yes, sir.
Okay. All right. Now we can hear. Okay. So, okay. So, as I'm saying a while ago, we have here a pop-up connection wherein, or a warning, call this one warning, ang tawag dito. Anyway, basta may warning na lalabas. Okay. Just forget the proper term. That's only mean that parang binabalaan ka yun. It's trying to warn you, okay, that you're trying to connect a certain connection to an existing connection. So, like for example before, there is a pop-up message wherein you really want to sure that you want to connect this DTR on the DTR right here. Okay. So, parang ganun, just click yes. So, meaning this one is physically connected now with the DTR connection. Okay. And then for the number 2, so we want to connect the RX right here to the number 2. Okay. So again, just put a floating net. Same with number 3, floating net. And just change the name of this one into RX. Okay. So warning, connect NS1 and RX. So just click yes. So it is trying to ask you that this NS1 before will be connected now to our RX. So the name of this wire now is RX. Okay, so this is now the official name or the updated name. Okay, and then this one also will be named as TX. Okay, so another warning, just click yes. So Are you guys done with this one? Okay, so Mr. Diet and Mr. Joshua and Mr. Tuwa is already done. Same with Mr. Arbizu and Mr. Miklay. Alright, so one more thing, okay, that I forgot to mention is right here we've just put a label name, right? So we just name it to connect to other wires. But in here, after naming it, you should use the label tool, okay, to add a text label with the label tool selected, left click on the net you just named. So this should spawn a piece of text that says ground. Left click again to place the label down right on top of your net. So maybe before, okay, before after naming the net, okay, so nothing will pop out. Like for example, we have this they don't have this ground, so for clarification they are adding a label, okay, which is right here beside the junction. They're adding a label wherein just clicking this wire right here will give you the name of that uh, net. But since maybe they've updated this one, since it already has a name, as you guys can see upon putting a name, it is already giving us a label at the same time. So you don't need to put a label anymore. Okay. So it's just that it was mentioned here because maybe before there is no name ground on each of those connections. Okay. It's just that it has its hidden name or it's not visible. All right. So no need to click for label since they are already labeled. Okay, so the next one right here is this one, this 3x2 pins. So we're also going to put some net stubs. Okay, and then we have the name MISO, SCK reset, and VCC is connected to VCC, and then ground is connected to ground, and then MOSI is has a net stub of MOSI. Okay, so let's do that one. So this one, just put some floating floating nets for now. And where is our VCC? Okay, so let's move this VCC right here down on the 2x3 pin, because this one will be connected to the VCC. Okay, so let's connect this one now. Oops. So it's yes. And I'll just move this one so that they are aligned with each other. And just net this one, so ground to ground. And MOSI will have a floating line. Floating net. Okay, so let's name them. So this one is still MISO. And SCK is still SCK. And RSD is reset. And then MOSI is still MOSI. Let's see. Reset. All right. Finish. Okay, so we're almost done. Okay, Mr. Joshua is already finished. And sino pa? Sino pang tapos? Okay, Mr. Daip, Mr. Daman, Mr. Kagiwa, Mr. Miklay, Mr. Pua, Mr. Magilao. Alright, so I guess most of you are already done. So in here, we now need to connect those pins to their respective connection. So in here, we have the reset. And then right here, MOSI is connected to MOSI, MISO is connected to MISO, and SCK is connected to SCK. So let's do that one. So since it already has a floating line, let's just name this one, okay, as reset. So from NS2, we'll change this one into reset. Okay. Let's say yes.
Okay, and then just put it there. And for the MOS right here, the PB3, okay, just put a floating line in floating net. I'm saying floating line. It's floating net. Floating net. Okay, and name this one MOSI. Say yes. MISO. Say yes. And then SDK. Just say yes. Okay. So meaning they are now connected with their corresponding connected pins or connection. So let me know once you guys are done. Okay, Mr. Arbis is already done. Mr. Duman, okay, Mr. Joshua, Mr. Bua. All right. So I guess most of you are already done, I assume. So the next one right here is naming the nexus. Okay, so we don't need that one. Tips and tricks. Okay, so here are just some tips and tricks before we'll proceed to the board layout. So for the names and values, so every component on your schematic should have two editable text fields, a name and a value. Okay, so this is an indicator that uh, that one is an official component that you have on your schematic. Like for example, R1, R2, LE3. So they have their own values and then they have their own specific names. Okay, so take note that every component on the schematic should have a unique name. Okay, so that is one very important thing. If there's two components which has the same name, so you might encounter an error. Okay, so you can use the name tool on any component to change the name. Okay, and one more thing that you also need to check is the name of the nets. So if you want to check the connection, so you should check the namings of your nets if they are really connected to the uh, specific connection that you wanted them to connect. Because if they have different names, and you're assuming that they have one name because you thought that they are connected with each other, but in reality they're not. So you have to check that one also before moving into the board layout. Because if we are not connected, yeah, if they're not connected, then you're just doubling your work, okay, or you're going to have a problem. Say you have already finished your board layout, but you've missed one connection, okay, then that will be a very big problem, okay. And what else? And yeah, I guess that's it. And verifying connections. So in here, this one is very helpful. Okay, you will see this I, or this one is actually the show tool. Let me just highlight this one. Okay, so this is a show tool. So this is very useful in verifying that the pins across your schematic are really connected correctly, or they are really connected with other pins for any other correction. Okay, so in here, if you will highlight, let's see, this one for now. Okay, oops. So just click this show, and then because it's not that visible. Okay, you will see right here that it's like changing the color from lighter to darker. Okay, so that's an indicator that they are connected, or this line, I don't know if you guys can see this one, this line is connected with this line. So if they are blinking together, okay, meaning this line right here is connected to this line. All right, so that's one way for you to check if they are really connected with each other or not. Okay, so we really have to zoom. You really have to zoom in and out whether they are connected with each other. And one more thing, okay, so instead of using show, if they are really connected with each other, you can just simply use move, just like the one that I did a while ago. So you can use move, and yeah, they should work something like that. Wherein they are not leaving the point where they are connected with that pin or connection. Okay, so that's an indicator that they are connected to this one, and this one. Or you can just simply move a certain component. Okay, so you can use group. Like for example, right here, I wanted to check if this is connection is really okay. So group, and then highlight this one, and then just move them together. Okay, they should not leave the pins where they are connected. Okay, so those are the ways for you to be able to check if they are really connected with each other or no. Okay, so are we clear with that one so far? Right? Okay. So Mr. Bisu, Mr. Kuwa, Mr. Daniel. Okay, so just like this. Okay, if you will use move or group, then it should look something like this. Okay, so meaning they are really connected with each other. Okay, so in here we have here the good and bad. So you will see this one if you will zoom on the specific connection. So there should be only a small dot. Okay, because in here this is bad because they are overlapping the connection. Okay? And there's a big chance that they are not really connected with each other. They are just simply overlapping each other. Okay, so in here just zoom in and zoom out. Okay, so this is good, this is also good right here. So this is good, and this is good. Okay, so those are the ways for you to check if this one has a good connection, or if they are really connected with each other. Okay. All right. Okay, so it's just another tip. So in case that you have this kind of connection, just delete that connection and then try to renet this one. Okay. And what else? So grouping or moving or deleting. Okay, so let me show this one to you guys. So if you want to group something, okay, you can always click this one. So let me check if there is a shortcut key for group. Okay, we don't have. Okay, so in here you really have to manually click this tool right here, and then just drag and drop. So drag and drop it, meaning you're already highlighted this component. Then you can now start moving this one by left clicking the crosshair of one component of that group. Okay. All right, so that's one way for you to group and to move a group of components. Okay. And then another thing is you can also do the double tap. Okay, so you can double left click, so it will give you a free line or free wire. So actually we call this one polygon before. I don't know if we still call this one polygon. So you can create a free size form. So inside of it, okay, will be grouped together. Oops. There you go. So just double click it again, and then you can now move the entire group. Okay, whatever is that component inside of it. Okay. So those are two ways for you to group and move a component. And then if you want to delete the group, so of course, just highlight that specific group and then Control D. Okay, and then click that specific groups. Okay, wait. Maybe we can drag and drop. No. Okay, let me just try this one. Delete. Okay, so the shortcut key is you have to group them first and click delete key on your keyboard, or you can click this one, but it's not. Okay, so maybe only the delete button will work because Control D, okay, because the official shortcut key of delete is Control D, but this one is not working. Okay, so just hit your delete button on your keyboard. That one works. Okay, so group and then click delete. All right. So are we clear so far? Well, of course, if you want to delete the specific component, just Control D, and then yeah, you can delete, start deleting some components. So are we clear with this one so far on how to move, how to delete, how to group? Okay, very good. And then for the copy paste, so this one works different on EagleCAD, okay, because in here, if you're going to copy, okay, you don't need to press Control V anymore. Okay, as soon as you click a certain component, let's say VCC, okay, it will give you a copy of that one, and you don't need to paste it anymore. Okay, so just place it on any place you wanted to place it. Okay, and then there you go. So you already have the copied component. And the paste right here. So what is a function of paste, sir? So the paste right here is actually, to copy an entire group and then paste it on another place. So you need to do is group this one first, and then uh, copy this one. Oops. There you go. Okay, so medyo magulo siya. Okay, so first you need to group and then copy. Okay, and then click paste. So it's a double process. So highlight all of them, click copy. So Control C and then Control V. Okay, and then you can place it anywhere you want. Okay, so let's try Control C, Control V. Yeah, there you go. So shortcuts work with this one. All right. So if it's a single component, you can use copy. This one right here. If it's a group, then you can use copy and paste. All right. Okay, so are we clear, guys? Are you guys able to follow? All right. Okay. Okay, very good. So what else? Okay. So that's it for the tips and tricks that you guys need to know for now. So the next thing is we now need to go to the board layout. Okay. So all you need to do is click this one. So if it's your first time going there, so it will give you a warning, meaning that you're going to create a new schematic or new board layout for this schematic. Okay, so in my case, I already have mine. So by default, all of your components is outside to our, let's just say that this is your PCB, the size of your PCB. Okay, so the first thing that you need to do is, of course, group all of this. And move this one, okay, inside, oops, yeah, that's a group. So group them and then just drag and drop. Okay, just click the crosshair of one of the component and then put them inside and then hit escape. Okay, so once you're done with that, you will have this one. Okay, are you guys already done with this one? Okay. Mr. Charles already done. Mr. Joshua. Mr. Brian, right? Okay. So this is the first mentality that you should have in creating a PCB. So the smaller the PCB, the better. Okay. The more that, you know, what is the proper term? The more that it's compact, the more the price that you can have if you're going to sell it on the industry. Okay. So the smaller the better, the smaller the more expensive. Okay. And then the more resources that you will be able to save. Okay. So uh, the one that you need to practice in here is, to route them in a very, very small PCB. Okay. So what you're going to do is first, you need to put the components on the, where they should used to be. Okay, so you should know where to put your microcontroller. Is it on the left side? Is it on the middle? Is it on the right side, upper, bottom, etc., etc.? Okay, so here's the thing. So it is always where the most important part of your circuit will be placed on the middle. Okay, so it could be on the upper right, on the middle, or bottom, not upper right, on the upper center, okay, of the PCB, or on the bottom. So it's okay as long as it's in the middle, and then the uh, sides of it, it's either the connections, the pins, the VCC, what else? And of course, the place where you're going to screw it. Okay, so remember the NPTH, the non-plated through hole. So we have non-plated through hole because this is where you're going to put physical uh, screw. Okay, where you're going to screw it on one place. So if you want to put it on a permanent place, then you should place it right here. So 1, 2, 3, 4. Okay, so just leave it blank because that is where you're going to drill a hole. Okay, and then another thing is, let's see, on this side, or on this side, on this side, or on this side. Okay, so that is where you're going to put the pins. Okay, because that is where you're going to connect most of the incoming connections, or the out. So mostly it's input. Okay, or just the VCC or the ground. Okay, the positive and negative. Okay, so if you're going to take a look on this one, we have the power and the ground right here. So you have to place it on the, so in my case, I'll just put this one on the upper left. All right, so let's move this one on the upper left. Then of course you can rotate this one. Okay, so in my case, I'll choose this kind of layout. All right, and the microcontroller is on the middle. So since I will resize this one anyway later on, so I'll just put it right here, because I will resize this one anyway into like this, okay, into a smaller PCB. And pins right here. So, oops. So that is a difficult part. So you have to look for the specific crosshair of this one for you to be able to move. Maybe right here will be good. And R1 will be right here. So the R1 in here is the one that is connected on my VCC. So if I will look for the VCC, is it this one? Maybe not. Where is the one that is connected to my VCC? This one. Okay, so the R4. Okay, so you need to find this one. Okay, so you need to find this resistor right here, wherein it is connected on the reset and VCC. So you don't want to place this on the right side, since it will make things harder to route. Okay, you want to put this one onto the nearest connection that it should be. Okay, so in here it is on the upper right. And for the LEDs, okay, so just align it something like this.
Okay, so again, good morning. So can you guys see my screen now?
Yes, sir.
Yes, sir.
All right. So again, as I've mentioned a while ago, this is already our last meeting. Why? Because if you guys are going to look on the date, supposedly we still have a meeting this coming Friday, but I didn't expect that this coming Friday or April 9 is actually holiday. So yeah, this is already our last meeting since next week, starting Tuesday, 13, 14, 15, will be your final exam already. So in total, it's like we only have 2 meetings in this finals. Well, anyway, since I have already mentioned the things that you guys need to do for the last requirements, so I think you guys have plenty of time, to think of a project. And some of you have already created the flowchart, the block diagram, schematic diagram. I think the only one that is missing is the EagleCAD version of your project, which we will try to finish the project or this presentation right now, not the project, because you know finishing a certain project in EagleCAD is might take you 3 hours, 4 hours, or even 5 hours, depending on your skills, on how you use the functionalities of EagleCAD. Okay, so before we continue our discussion from what we have left last meeting, okay, so do you guys have a question so far? Question or clarification regarding with this one up to this point, up to slide 53? Question? None? Really? None? Okay, so that's good then if you guys don't have a question. Anyway, so if I'm not mistaken, this is where we have stopped. So we are already done with this one in board, generating the board layout. And are we at this point already? Or are we done with this one already? So to those who can recall, where did we stop from our last discussion? So are we done with slide 3 with Eagle's layers? Have I discussed this one already? Not yet. Anyone?
Not yet, sir.
Not yet.
Not yet, sir.
All right then. Okay, so there are only 4 parts that you guys need to worry about layers. Okay, so of course the first 2 are important is top and bottom. Okay, so if you're a beginner, of course you're only going to deal with top layer, and then let's say you're an amateur already. Let's say you already know at least 50%, okay, on how to do something about the top and bottom layers in EagleCAD, then you can deal with top and bottom layers. Okay, and then let's say you're still a beginner, and then you're only done in dealing with top and bottoms. So the next thing that you need to do is finish or finalize your project. So we need to take note on this one, the T place and B place, which deals with silk screen. Okay, the top place and then the bottom place silk screen. Okay, so basically those 4 layers only, and then the rest are maybe helpful when it comes to viewing about pads, viewing about bias, viewing about unrouted wires. You have T stop, B stops, and then some holes. So yeah, this one is also important, but not that much since that is just a hole. Okay, and some documentation like text documentation, etc., etc. All right. So yeah, that's basically the top, bottom, and then the T place and B place layers on our EagleCAD. And the next thing right here is selecting from overlapping objects. Okay, so let me just show this one to you guys. So to make it quick, I will not read some of the parts anymore. I'll just I'll give you a quick demo. Okay, so we have here a top layer, which is the red one, and then a bottom layer wire, which is of course the blue one. Okay, so let's say you wanted to pick one of them. Okay, so let me just open our last project. So this is where we have stopped last meeting. Yeah, so I didn't touch anything as soon as we have stopped with our discussion. So again, let me just arrange this one real quick. So the one thing that we need to check is the placement again of your components. So if it's a pin, so it should be on the left side or right side, or on the top side or bottom side. Okay. And what else? So I guess this one is already fine. So let me see what is our final output. Something like this. So we have 3 LEDs, 3 resistors, and then the 8 pins right here. Okay, R1. Where's this one? It's at the bottom. Right there. This is the D2 for the second LED. And this is the second resistor, the third resistor, and then the third LED. Let me just move this one. It's not that. So I hope that you guys did an advanced reading, or did you have at least finished this one at this point. Were you guys able to do this one, arrange the proper arrangement, something like this, whatever we are seeing here right now. And this one is placed right there. Right, so I think this is very good. Oh, we have, what is this? What is that 2 pin in there? No more pins. All right, so I don't know what this pin is, because this is my first project when I was doing the presentation, and the one that we are doing right now is a fresh project. So maybe I miss one object or one component. How about your project, okay, or this project that we are creating before? Do you also have that component in here? This one?
Wala naman, sir.
Wala, no? So I think that is a mistake that I have added. Okay, that is maybe a component which wasn't supposed to be in there. Anyway, so this is already the arrangement. And let's find an overlapping wires. There's a 2 wire. Okay, so let's have this one. So as you guys can see, we have just imagine that they are overlapping. So we don't have the red one and then the blue one right now, since we haven't routed the air wires yet. But for now, let's say they are overlapping, and then you wanted to choose one of those wires. So of course you have to left click, okay, and then you will see a slight difference wherein the wire that is glowing is the one that is being picked. So you will see right here. So we have an information down below on the left side bottom. So it says here that this one is BCC. Okay. So it says here left if that is the one that you really wanted to choose or you wanted to pick. Okay. And right click if you wanted to move to the next wire or component below that. So if I click right click, then the other one now is being picked, which is SEK. Okay, so that's how you choose an overlapping wires or air wires. Okay, just right click and then you will see down below. I don't know if you guys can see that one, but it's changing the name. So VCC and then the other one is SCK. Okay, so are we clear with this one on how to, this one, on how to select an overlapping objects? Oh, guys.
Yes,
So
sir.
right here,
Yes,
just
sir.
right click and then
Yes,
be
sir.
able you to switch. Okay, very good. So just let me know if there is a part that you guys were not able to understand. Okay, so in here, actually we're already done with this one, arranging the board. So again, the one that you guys are seeing are the air wires, the gold lines. Okay, those are wires that you need to route okay, later on. So the first job in the PCB layout will be arranging the parts and minimizing the area of our PCB dimension outline. So PCB costs are usually related to the board size. So basically, of course, the smaller the board or the PCB, the more that you can save. But at the same time, the smaller the board and then the more it is, compact, the more that it is more expensive in electronics industry. Okay. So yeah, basically the smaller, the better. Okay. Because that's what we wanted in our technology right now. Okay. So, a very powerful small PCB, that can do everything already. Imagine having a very small PCB and then, uh, the rest are just spaces. So in that case, you'll be able to, save more money for your production, okay, and then you'll be able to sell it more expensive, much more expensive, because you were able to come up with a very very small PCB. Anyway, and then the next thing that you wanted to do is understanding about the grid. Okay, that's because while let's say routing is one, let's say you went to route some of the components ready. Let's say just click this route here, route air wire. Okay, so again, do not click line. Okay, that's a different function. So the one that you need to choose is route air wire. You just click that one, left click, and then let's say you wanted to route this one, reset. Okay, so the red one indicates that this one is on the top portion of the PCB. Okay, so you can also change the angle, okay, just by right clicking, okay, your mouse, just by right clicking your mouse. Okay, well, you can choose the default angle in here already. So we have 90 degrees, we have 45 degrees, we have a straight line, then we have a slightly concave, and then we have a concave, a much more concave line in here, and then we have a free air wires that doesn't have a default degrees, so it's a free air wire. So what we always choose, or the standard one when it comes to putting lines or routing air wires is always 45 degrees. So it's either 45 degrees or you can choose this one, the slightly concave. I mean the concave one, not slightly, because this is the one that is slightly concave, and then this is the concave angle. Okay, so it's either this one, or you can choose 90 degrees. So in some cases, this one is also being used, but mostly it's the 45 degrees and this one. Okay, so depending on your preference, so either of those two. Well, in my case, I always use 45 degrees, so I will be using this one. Okay, so the one thing that you need to do is always put it closer, on the component itself. So you don't want to, put it right here and then wire in right there. So it's should be always closer on the component. Okay, the shorter the air wires, the better. Okay, so it will help you. It will help you arrange the components later on easier. So one thing that you're also you will notice is it doesn't give us a uh, finer placement of our wires, because supposedly I would like to place it right here, okay, below the dot, but it doesn't wanted to go in there. So the one thing that you need to edit, okay, is the grid. Okay, so just look for this icon, grid icon. Okay, just left click that one. So by default, it's 50 milli, whatever is that. But the one that we always choose is inch. Okay, so just go to inch. Okay, and then change the size from 0.05 into 0.005. So we have two sizes in here actually. So we have the default one that we are using before. So before it's set to 0.05, but we wanted to set it to 0.05 for finer placement of your wires. Okay, 0.05. So this one is actually the alternative size of your grid, but we don't want to, click Alt from time to time, because you can only activate this Alt if you will click or if you will hold the Alt uh, button, okay, or keyboard, right? Alt keyboard, no, Alt, matawag dito, button, button nga. Okay, so let me know kung ano yung tamang correct term for that. Correct, I mean, yeah. Ano ba? Button, no nga. Anyway, button, alt button on your keyboard. All right, so from there, just route this one again, and you will see that it is now giving you a finer placement of your wire. Okay, so that is already a big improvement, because you can place it on the place that you wanted. Okay, so below the dot, to make a straight line before that reset pin. Okay, so let's route this one. Oops, it's in the other side. So let's route that one later on. And what else? Anyway, so let's just move on while discussing the slides in here. So in here, by default, it's 0.05 and then 0.05. So again, just change the size into 0.005, okay, which is much more better, or much more finer, okay, when it comes to placing a certain wire. Okay, the next one right here is moving tools. Well, you guys already know this one. Just click this move icon, and then you'll be able to move a certain component already. Okay, again, just look for the crosshair of that component, like for example this one, for you to be able to move the entire component. Because if you will just click, okay, wherever, okay, of that component, you will not be able to move this one properly. Okay, so you have to find this crosshair right here. That's to indicate an indication that that's where you have, or where you can move this component. All right. What's next? So the rearrange image. Well, these are already common sense. So don't overlap parts. So you don't want that to happen to your PCB layout, and minimize intersecting air wires. So of course, that's already a common sense already. You don't want this wire to be, intersecting this one, like because it will not allow you. Okay, though you can set that one into ignore obstacles, wherein it will allow you to pass through that obstacle or object. However, this one is already wrong, because it will short those two wires, wherein it will only destroy your PCB, okay, or your components. So change that one into walk around obstacles. So that's always the best option. So the third one is actually also okay. Yeah, you can forcefully move some of the components, okay, or the wires, like that. Okay, but in my case, I use this one. But if you want, you can use this one if you want. But in my case, I always use the walk around obstacles. Okay, so in that case, I am not bothering, or I'm not moving the other wires. All right. And what else? So part placement requirements. So some parts may require special consideration during placement. For example, you probably want the insertion point of the barrel jack connector to be facing the edge of the board. So as I mentioned a while ago, the placement of your components is very important. So like, for example, this barrel jack right here, or power jack. So it should be on the edge of your PCB. So yeah, you can place this one on the middle, but it's not ideal because this is a power jack wherein you wanted to place it on the edge so that you can easily put the jack. Okay, so not on the middle part. And yeah, I guess that's it for moving parts. Next one right here is, well, I'm already done with this one. Actually, we are at that point already. And then adjusting the dimension layer. So in here, you can adjust the size of your air wires by going. So just choose the air wires first, and then it will show you the property or properties of that air wire. Okay, so the width that we have in here right now is 0.006, which is not actually good or recommended, because the recommended size of air wire is 0.008. What do we have here right now? 0.006. Yeah. So make this one a little bit bigger into 0.008. Okay. Why? Because where is that one? Where is that reminder? Then start. Anyway, so why do we need to set it to 0.08? That's because current need a certain size of air wire, okay, or the size of wire that it will flow to. Because if it's too small, then that is not good. It might overheat your wire, which will make your PCB being destroyed. Okay, to burn your PCB. And let's say 0.010 or bigger than let's say 0.09 or 0.010 is not also good. Okay, because you're only wasting the amount of current that is flowing on your wire. Okay, so you don't want to have a high flow of current on your PCB. So you only want the exact amount of exact amount of current and then exact size of your wire. Okay, so that is why in some or in most cases, just always choose 0.08, so you will never become wrong when you choose this option 0.08. So in some cases, they required you to change the size into 0.09 or 0.010. Okay, if that component needs more current that will flow on that component. All right. So yeah, but by default, it's always 0.008. Okay, so I hope we are clear with that one. So once I saw that you were using 0.07 or 0. What is that one? Where is that limitation? I think it's on the next slide. Right here. Okay, so smaller than 0.007 is not good. Okay, because you will probably end up paying extra. So what it mean by paying extra is your entire components might not work properly, or it will burn your entire components just by having a smaller size of wire. Okay, so 0.08 is the best one because that is the standard. And then bigger than that, and where is that one? Anyway, so I cannot find it anymore, but bigger than that is also okay, but depending on the components that you are using. All right, so what else that you guys need to know about wirings? So in here, you can also change the shape of your vias, okay, but mostly it's spherical. Well, you can change it to rectangle or something like polygon, but mostly it's spherical, okay, because the size of the drill is spherical. We don't have a size of a drill which is polygon. Maybe there are some pieces, but mostly it's of course a circle, okay. And then here's the drill size, okay. You can change that one into whatever size that is needed to your PCB, but mostly the default one that already set in here is the best option. Okay, and then the diameter is auto, so don't change that one anymore. And then you can change the radius to 0.1 or 0. Okay, so well, 0.1 is good so that you can have a small radius from the other components or from the line that you're having here right now. Okay. All right. So what else? Routing board. Okay, so I guess I'll just show this one, okay, manually. Okay, so routing board or routing the wire is super easy. Just left click this route air wire, and then yeah, it's like what we are doing right now. And what else? And here are some good and bad way of routing things. Like for example, okay, I'll place it super close onto our next component. Okay, and then let's say that's it for now. Okay, so you will know later on why this one is super bad. You know, being super close to the other wires is super bad because there is a tendency that you know, if a small object that conducts a electricity, okay, wherein say they touch each other because of that component or because of that object. So there's a big chance that it will short your entire component. Okay, so you know, having a larger space is also okay, but yeah, the best one is of course the more compact the better. But clearances is also a big issue when it comes to PCBs. So one way for you to be able to check this one is go to BRC. So left click this icon right here, this down icon, and then check this, click this DRC right here, and then by default, so it already has a settings wherein it can check the layers, the clearance, so it only has a clearance of 6 millimeter, a distance of 40 millimeters, 6 millimeter for the drill holes, etc., etc. Okay, so for sizes, annular ring, shapes, supply, etc., etc. But there is a file that is actually one of the latest way of checking the errors of your PCB. Okay, so the one that I have here is the file of SparkFun. So I'll show to you guys later on where you can download this one. But for now, okay, let me just open this one. So once you have loaded that one, then that's already okay. And then click check. Okay, and then you will see right here that this will give you errors wherein 50 errors wherein we have 43 air wires. We have 3 clearances or 3 clearance. So for the air wires, of course, we have a lot of errors on that one because we haven't routed the wires yet, some of the wires. So in here, in clearance, so if you will click those, so just double click and then it will show you where is that error or where is that specifically. So yeah, as you guys can see right here, we have a clearance error in here. That's because it is saying that, you know, this component or this wire is too close to that other component. So that is not good. So you have to adjust this one. Okay. So it's either you rip up this one, okay, rip up that wire and then reroute it, or you can move it, okay, like this. So in that case, you'll be able to remove that clearance. So as you guys can see, we don't have a clearance error in DRC error anymore. Okay. So for the others, so for the weed, okay, just double click that one and then it will tell you the error. So it says here the width of your air wire is not good. Why? Because the air wire that we are using before right here is 0.006, okay, which is smaller than 0.007. Okay, so the one that we have used, okay, the recent one is 0.008. So as you guys can see right here, this one is a little bit bigger than the previous air wire that we have used before. Okay, so yeah, as early as of now, you guys should be checking that one by one while routing some of your air wires. So the sooner that you are solving the errors, the better. Okay, you don't want to, have so much error and then just fix everything once you're done in routing your wires. So, once you're done in routing 1 or 2 wires, so you should always check if you have errors. All right. So I hope we are clear with that one. Any questions so far? Question, guys? So is my voice clear? Can you guys hear me clearly?
Yes, sir.
Yes, sir.
Okay, baka kasi may noise ulit eh. Alright. Okay, so moving on. Okay, placing VS. Okay, so VS is very important, especially if you have, a lot of intersecting wires. However, this is one thing that you guys should call this one should know. Okay, one thing that you should know once you are placing vias. Okay, so once you have placed vias, the layer or your one layer, your top layer will now become 2 layers, which will double the price of your PCB, because instead of having one layer only, you are now designing 2 layers. So even though it's just one vias, you now have the bottom layer. Okay, so basically you have to print 2 PCB layout now, okay, instead of one only. So as possible as you can, route everything in top interface only. Okay, do not try to have at least 2 layers. Okay, so of course the more compact the better, but having 2 layers is like having 2 PCBs already. Okay, because you will print 2 PCB design in one PCB board. And another disadvantage of that one is you won't be able to place that one, okay, in one placement only, wherein you will be able to place the entire PCB in a flat surface, because you now have some components down below. Okay, so instead of having one components only on the top, or most of the components on the top, but choosing to have the bottom layer will give you that limitation. All right, so let me just show you guys how to create a VS. So for example, I need to route this. Let me just wrap up this one. I need to, oops, Control Z. Oops. So as you guys can see, this one is connected right here. Okay, so let's say I need to place that one on the bottom side. So just click your scroll button. Okay, and then it will give you this VS. Okay, this is actually just a hole wherein meaning that this one now is connected on the other side. So as you guys can see, I can now easily route this one on the other side. Okay, like that. So I have, let me
Sir,
just,
Sige.
ano yan?
Sir, regarding yung top and bottom na ano yan tawag din, yung trace, yung copper traces na yan, pwede bang sa bottom layer yung traces niya? Kasi yung component na i-install mo sa top side tas iso-solder mo sa bottom side, di ba, sir?
Well, parang top na rin yun. So basically, the one that you guys are seeing here, okay, the top one layer is yun yung nasa ilalim. Okay, because the one that, ano ba? Papakita. So this is the top portion of your eagle gun, right? Let's say we have red wires in here. Okay, these are the holes or the pins. Okay, so if you will print this one, so in reality, this is actually the bottom. Bobo ka mag-drawing. Well, sorry for the word. That is actually the bottom portion. All right. Okay, because you will place the component at the top. Okay, like for example, this is your microcontroller wherein it has a lot of pins. Okay, so the wires or the routes is actually at the bottom. Okay, so
Okay, sir. Gets.
I know. Well, you can have actually you can have a layout also wherein top portion only, but your component is at the top of that layout. Okay, so in some
Some parts
some
kasi,
component,
sir, dapat iso-solder mo lang sa bottom side, hindi mo ma-solder sa top side.
yes,
Diba?
yes, like resistors and yeah, capacitors, LEDs. Those components, quasi pins. Okay, so this is where you will solder it. We're in at the bottom side, and then this is the part wherein we have the PCB layouts at the top. Yeah. So I almost forgot. Yeah. So you were correct, Mr. Karina. So thank you for that. So some of the components will also overlap, okay, the bottom components because it has wires like this. So that is one thing that you guys also need to consider when you have a bottom components. Like you have a bottom layer right here. So some of them are under wherein you have the capacitor here and then you will put it right there and then the pins will pop out on the top layer. So yeah, you won't be able to solder that one anymore because it's being covered by the other components. So parang ganun. Anyway, so you will realize this one soon as you have the actual PCB design. Okay, because as of now it's just a picture. Okay, so you won't be able to appreciate it unless you do that one on actual PCB. Okay, so me myself, we're only able to do the top layer before, so that is why I don't have any problem even though I have my pins on the bottom side of your PCB. So all of my components are at the top layer only before on my project on the this subject. Okay, but right now since we are at the stage of learning, so I would like you guys to experience to have a bottom layer. Though even though this one is much more uh, reliable when it comes to designing, but it's much more a lot of work when it comes to implementing it on a PCB because you're considering two layers, the top and bottom. Anyway, so any other question? I guess all of you are already in here. Any other question or clarification? No.
None, so.
No, guys.
Okay.
Answer.
Alright, sige, baka
Yes,
kumakain yung iba. Anyway, so the one that you guys are seeing here, so it seems like they are overlapping, but they're not since the red one is on the top layer and then the blue one is on the bottom layer. Okay, so this is just a hole wherein you have to put a LED on that one so that they can have a connection. All right. So the next one right here is route clearance. So we have already discussed this one while we are or while I'm showing BRC errors a while ago. So just check for clearance error and then just double click that one, and then you will see that it has something like red teeny, and that meaning the clearance is not good. So just reroute it. You just delete that trace and then reroute it. All right, so the next one right here is the finish project of the this one that we have here right now. Okay, so that's about the simple rules there are. Go ahead, time or something. Yeah, so it is something like this. Okay, once you're done in routing everything. So this one is already a good project where it doesn't have any error. Okay, but that's not the end of it. Okay, so of course, this one's not yet done since we have to add still screen later on. But once you're done with that one, so I would say congratulations, since that's the hard part in designing a PCB. However, okay, let me introduce to you the auto route. Okay, so I don't know if you guys have done this one already, but we have this auto route in here. So this is a function. Okay, so let me just erase my components to show. I mean, not components. Erase my recent routed wires. Okay, so we have a fresh unrouted area wires in here. So the one thing that we will do is click the auto route. Where is that one? Right here. So auto router. So I would like you guys to do this one also. This is very fun, especially if it was able to design your circuit or your PCB layout properly without having any error. But I doubt that it will not have any error. It will give you a lot of errors actually. Okay, so you can choose the effort in here. Okay, so we have low, medium, and high, but of course you always wanted to go to high effort, okay, of your CPU. Okay, so the maximum number of running threads is 8. Well, if you have a say not that powerful desktop or laptop, you can lessen the threads that is running. But in my case, I already tested this one. So even though my laptop is not that great, so it was able to, route the or my PCB layout properly. Okay. So just click continue, and so by default, so everything is 0%. Okay, it will show you how many percent that's already being covered. So just click start, and it's now starting to analyze and optimize everything. So it is now routing it, okay, by itself with the use of my CPU only. Okay, so I'm not using my mind in here. So I let my computer to do the work. All right, so in that case, I will be able to save more time, maybe. Okay, so this is 50-50. So in here, as you guys can see, we have a 95.5% job that is being done, and the rest are 100%. So the rest that is unfinished, this maybe needs more uh, edit. Oops, I wasn't able to click the end job. Anyway, let's just do that one again. Oops, what happened? Eagle, the board, and save. Yes. Okay. Evaluate. Oops, my bad. So there is a component in here wherein it's supposedly at the top one. This one right here. Let me just move this one. All right, so let's do the auto route again. Let's see. Yes. 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 Why? Stop. Oh no. Something happened to my PCB design. So I don't know what happened, but my air wires now are gone. And I keep on choosing yes. There you go. You also want to load Eagle projects budget. Yes. All right. So I hope this one now is okay. Okay, let's try auto route again. Okay, I will not click that one. I'll click cancel. What? So I'll start over again. All right. So once it's done, okay, let's say everything is already 100%. Just click end job. The one that I did a while ago, that's why we are having an error, is I click cancel or I click escape. So do not do that one. Okay, just click end job. Okay, and then if you're happy, okay, with the result, then yeah, you can adapt this one, or you can check the errors by going to DRC. Okay, so this is the designs rule check. So again, just click load if you haven't loaded the file yet. But since I have already loaded the file a while ago, which is this one start time, so just click check. And as you guys can see right here, I just have two warnings. Warning with war stub. So meaning, so this is my first time encountering this error. What is this war stub? Well, I think this is already okay since this is just a warning. Okay, it will doesn't have any error, so we're fine. But let me just try to rip up this one. There you go. I see. So that's just an overlapping routed wire. Okay. So what I did is I just ripped up that in there. So double click this one. We have another wire stub warning here. So just rip up that one and then remove that wire. So we have one air wire. Actually 19 air wires. We have one error. So let's try to delete and reconnect. There you go. So we don't have any error now. See? So that's the help of auto route. Okay. However, if it gives you a lot of error, this is actually my first time not encountering any error. Okay. So I was shocked that it didn't give us any error because in my previous routed airwire, it gave me some errors wherein, as you guys can see right here. Oops. There's that one. As you guys can see right here, the spaces or clearances of my air wires is not that tight. Okay. So one thing that you will be able to know if this is made by auto route is if the clearance that is we have in wires is super, super wide, super wide, meaning that is done by human. Okay, and as you guys can see right here, uh, mostly if it's something like this, it is done by auto route function of the EOCAD. Okay, something like this. And yeah, we have some
We don't have actually a VS. So we don't have a VS, we only have a bottom layer, which is the blue one. Okay, so that is also a good thing because we don't need to drill a hole anymore. Anyway, so yeah, and this is perfect. Since we don't have any error anymore, supposedly I will show you to, you know, how to fix those errors if ever we have. But since we don't have any error, then that's it. You're already done. So how about your projects, guys? Have you guys encountered an error when you click the auto router, or when you've used the auto router? So
Wala naman,
who's
sir.
here who encountered an error when you've used auto router? None? So that's a good thing. Okay, so you're also lucky if your project right now we're also or doesn't have an error. Okay, when you click auto router. Anyway, so what else that we need to discuss when we're done with that one? Okay, so rat's nest. Okay, so we're almost done. So in here, all you need to do is click polygon. All right, so just click this one and just follow the line or dimension that we have in here right now. Okay, and as you guys can see, this is a top portion of your rat's nest. Okay, so you don't need to be precise as long as the components is inside of this rat's nest, then that's already okay. Okay, so make sure that you are ending it on the starting point so that you'll be able to close the polygon. So let's name this one ground. Okay, so what we wanted to have is this entire PCB is connected to ground. Okay, so once you're done in rat's nest top portion, okay, I mean polygon, okay, just click rat's nest. Okay, and then it will give you this kind of uh, PCB design. So in here, since our this red one right here is connected to ground already. So one thing that you will notice is the ground pins doesn't have any connections anymore. Okay, because they are already connected with the ground uh, or the red thing in here, whatever is that. Okay, so that's actually a connection. Okay, so this space that you guys are seeing right here is, an indicator that this one is not connected to ground because the entire red is actually the ground. So this is another connection, which is DTR, okay, which is separate connection. All right. So once you're done with this rat's nest, another thing that you can do is again click BRC if everything is okay. Oops. Then just click check. So it says here, BRC, no errors, left click to start polygon. So it seems that we don't have any error, then we're good to go. So yeah, that's it for the rat's nest for the top layer. So you can also draw another polygon, okay, for the bottom layer. But before that, we have to remove the rat's nest, okay, that we have in here for the top portion layer. So just type here, flip up, space, add, and then semicolon. Okay, and then click enter, and then it will remove the rat's nest inside of our PCB. So don't you guys worry, our polygon is still in there. Okay, so just click rat's nest again if you want to check something, and then just type flip up, add semicolon if you want to remove that rat's nest. Okay, so the next thing that we need to do is again draw another polygon for the bottom portion. So the one thing that we need to check is
bottom layer of your PCB design. Right? Okay, and then we'll also name this one ground, and then click rat's nest. So in here, before we have a line in here for the ground, okay, which is the blue one. But as you guys can see, it is or the what is that one? The routed air wire is now gone since it is now connected to the ground rat's nest of the bottom layer. Okay, and then if it's not connected to the ground, then it will also it will still show you, okay, the faded color of that wire and then their names, okay, BCC, NS4, etc., etc. So yeah, this is also connected to ground. And then again, just check if there are errors. Check. So DRC, no errors. Left click to start modeling. So once you're done with that, then you're good to go. You may now proceed and start putting some text or labels, okay, or the silk screen that we are calling. Okay, so design will check. So we then right here. So you can download the design rule check that I have. Okay, this one also came from SparkFun. So just click this one. Okay, control left click. It will lead you to their website. I mean, not their website. Okay, it will actually automatically download the file itself. So the name of that one is 52024 blah blah blah. So just move that one. Okay, move that one to the Eagle CAD folder. Okay, so the 9.6.2. Oops. Ayan niya. Anyway, I'll just paste it there. And then extract this one. Okay, extract as a folder. And this one. And just double click that DRU. And then this is now the Eagle design rules of this pipeline. Okay. So yeah. Just download that one right here. Okay. So any questions so far, guys? Okay, so we're almost done. So this is just the design rule check, blah, 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 whatever that's saying. So just read that one. Okay, so if it says DRC, no errors, then congratulations. But if you have some errors, you have to check those errors. Okay, so here's how I will check your PCB design, your schematic and board layout. So number one, if there are no errors, okay, then that's already 50 points. So it's like 50% perfect already. And then the next thing is how compact your schematic is or your board layout is. So if you could make this one super compact, like, you know, a smaller PCB, smaller dimension, then the better. Okay. So don't you guys worry, I'm not that harsh when it comes to grading a PCB, as long as I saw that it doesn't have any error, and then the way that you routed your components is very presentable, wherein the ground, I mean the pins or the power jack is on the right placement, then that is already perfect. Okay, so I'm not expecting a very professional design layout, but if you guys can do that one, then worse, that's perfect. So meaning you have a future in designing PCB. And what else? So these are the things that you guys need to know, of course, when it comes to design rule check, clearance, there are components that is overlapping the dimensions, and if there are no air wires that's left, etc., etc. So once you're done with that, And what else? Still design rule check. Okay, so this is the rat's nest of the top and bottom. Okay, so you will see something like this. Okay, we have the blue one for the bottom part, and then the red one for the top portion. And so in here, if you want to remove the rat's nest, so you can click clip up tool and then hit the polygon border. Okay, but in my case, I'll always use this one so that I'm not removing the existing polygon that I just draw. So again, just type rip up and then add and then semicolon. Okay, in that case, it will remove the rat's nest on your PCB design. And then adding a silk screen. So in here, well, this one is optional, but for the sake of learning, let me show to you guys some of the things that you can do. So let's say you wanted to put your name, who designed this PCB. So just click text, okay. But before that, you have to change this one, okay. So the top and bottom is already in there, the red one and blue one. But the one thing that you need to do is change that one into P place or B place. So P place is for the top portion, okay. And click text. So let's say design by Manpoy Saavedra. So it will show you this text, a white text. Well, you can edit this one. Okay, you can edit the color of this text by going back to that key place. Just double click. Oops, doesn't break. Where is the color modification? Wait a second while I'm trying to figure out how to change the color because it's possible. I think you can change the color into yellow, green, or whatever color you want. Key place. All right, so I cannot find it. Anyway, so if you guys were able to uh, find it in the future, then that would be perfect. But yeah, for now, the one thing that I'll teach you is how to change the size. Well, anyway, it's already here. So you can change the size of that text. So you can go to 0.8 to make it bigger or 0.24 to make it smaller, etc. Okay. The standard is 0.07. And you can also change the ratio, okay, into, this is actually the thickness of this font style. Well, for you to be able to see the result of this ratio, you have to change this proportional into vector. Okay, so as you guys can see, this one will become bigger. So it's in 28%. I'll make it a little bit thinner. So right there. So we have 11% of ratio. And yeah, so the alignment, so you can, just click, right click of your mouse to change the how do you present it. Okay, or you can mirror it if you want. Just click this one mirrored. Okay, but of course, since you are in a top layer, it should be not be a mirrored function. So yeah, you can do that one. Of course, you can also add more text for the R1. So this is your R1, and then R2, and R3. So just click escape to go back to the text editor, and this is your artwork. Right there. So, and let's say one more. See Atmel 328. Just put this one right here. So this one now is depends on the designer.
So if you want to add some labels, then better. This one is LED1, LED2, LED3, Atmel 328, capacitor, etc., then better. So the next thing that you can do is hit brightness to see how visible the text that you have put in here. Supposedly, I will change the color of your, the text right here into yellow to make it much more visible. Since yellow is one of popping colors. Anyway, we have gray in here. I think that's already visible since it's already quite big. And yeah, you can add some text, some shapes if you want, some art, some rectangles, some polygons. You can even add some bars, and those will not affect. Okay, those will not affect your PCB design since those are just text. Okay, so it will be part of the printed part of your PCB. And what else? So this is the result if this is how you want it to be. So we have here the ground, A0, A1, the pins, VCC, etc., with Mega 328. And yeah, so that's how it look like or how a finishing product look like. So as you can see right here, it's overlapping your wires. So again, it's okay. It will not give you any error, okay, since it's just a text. Okay. So it doesn't or it will not affect your routed air wires. Okay, so the next thing that you can do is generate gerbers, okay, or gerbers. Okay, so this one is actually the general files that will be generated if you wanted to, submit your design into a certain manufacturer. So for you to be able to generate a gerber file, just you can click CAM processor. Oops, where is it one? Click this one, CAM processor, and then just click yes, since this is your first time, so it will give you an error. I mean, not error, a warning. Okay, so the CAM output will be based on the save version. So yes, so whatever is this final output of yours will be saved as it is, okay, in a gerber file. So the next thing that you need to do is load job file and then new CAM job or open CAM file if you have an existing file. Well, in this case, let's download this one. So we can download the CAM file of Spark1. So again, just left click and then paste this one onto our EagleCAD 9.6. And then paste it right here. And then extract. So the ending number is C. So that's the one that I'll remember since the other one is also starting with 5. Okay, just open compile and go to that folder 9.6, 9.6, and then this one, and then come, and then that Eagle compound. So just click open. So it will generate the top cover, the bottom cover, the top still screen, the top piece. If ever you have top still screen, that it will also generate a file for that one, etc. So yeah, supposedly there are things that you can do in here, but we don't have enough time anymore. So the quickest way, and since we already have a file, okay, a formatted file by Spark1, so just click process job. So they've already done the job for you. So the same with the DRC check. So we have the file wherein it's the standard format, okay, that is being used right now. So they've done the format, and then all you need to do is just click the button. And then, of course, just choose where you wanted to save the files. So let's say in my desktop, and let's say Gerber generated Gerber. Oops, of course, we have to create a new folder. And then generated Gerber.
Generated. Okay, and then just left click that one, and then select folder. Okay, so just click yes, and then yeah, that's it. So job processed successfully. So you can open that folder, and then you will see here the you will see many types of folders. So we have GBL, GBO. So we have their meanings in here. So GBL stands for bottom cover, GBO stands for bottom silk screen, GBS for bottom solder mask, etc., etc. So those are the things that we'll be needing to submit, okay, to a certain manufacturer. So in other countries, so we have OSH Park, okay, so that is a company wherein we manufacture a PCB design. So just send this generated Gerber files, then yeah, so they will create or they will manufacture your design, your PCB design on Ethernet. All right, so we have other companies like Advanced Circuits, Gold Phoenix, Lydiada, and many more. Okay, so here in the Philippines, I'm not that familiar yet because the one that we are doing is manual. Okay, wherein we are the one who's creating our PCB. Okay, we don't let the other companies to make our design PCBs in Eagle. Okay, so we are the ones going to create it one by one. So we will buy the PCB, and then we're the ones going to put the design layout in there, and then we're going to drill it one by one. Check that, check that. All right, so we're almost done. So those are the things that could be generated, GPL, etc. And yeah, we are already done. So we still have 1 minute, but that time is not enough. Okay, so I will end our meeting for now, and then we'll just continue the rest on part 3 because there are still things that I need to mention. Okay, I need to discuss. So yeah, goodbye for now, and see you guys on part 2. So if you guys have questions, so just save it on part 3. Okay, so yeah, see you guys on part 3.
Sir?
How about you guys found it on SparkFun? SparkFun libraries. So open library manager.
Spark fan outlets.
Okay, so just wait, it's still loading. So we have here available libraries on the internet, and then just look for SparkFun. So one name in industry when it comes to PCB designs is SparkFun. So I think they are one of the most complete SparkFun ICs. I mean IC controller, microcontroller. So just uh, import this one. Try to import this IC microcontroller SparkFun. If not, you can try what else. Word is already has been here for a very long time, but I've never used your libraries. Word assembly, word capacitors, word automotive, microcontrollers. I think they don't have microcontrollers. Yeah, so just try SparkFun for now. If you cannot find it, maybe you can search a datasheet or a website for libraries for EagleGAD.
Yes, sir. Wala kasi
So
yung
let's try to use this
specific
one.
IC.
Ano yun?
Sir, yung specific na IC kahit Basta yung magkatugma lang yung traces niya. Ay, yung package
Oo nga
niya.
eh. So, another way that you can do or use is a generic microcontroller, as long as they have the same design, even though the specific model is not the same. As long as they have the same, arrangement of pins, and they have the same dimensions, width or the size length, then that will also okay.
Okay, sir.
All right. So before we continue this one, do you guys have a question so far? Aside from Mr. Carino, so let's address your query later on.
Yes, sir.
Question or clarifications over, guys? So, okay, so none. Coming from Mr. Sinizal. And coming from Mr. Eda. How about the others? All right, so I guess none anymore. All right, so this is already the last part. Okay, so you guys will not generate a Gerber file, since the one that I wanted to see, or the one that I want to see, is an image file. So basically, you will export it and then click image. But this is one thing that you should not do. Okay, so let me just show this one to you guys to see why you should not do this one, export as an image. So the at least minimum resolution that you should put in here is 600, and then the file name is, so I'll put here bad uh, or not clear, or not good PC. Okay, and then click monochrome, because you won't be able to use if it's colored anyone. If it's colored anyway. Okay? So just click monochrome, so it will make your design black and white. Okay, and then just click browse where you wanted to save it. So I'll just save it right here. Not good. EagleCAD exported image layout. So I have already imported one. Then just click OK. And then that's it. That's already in there. So desktop, not that. Where is that? I think it's on the pictures right here. Okay, so the one that we have exported as an image is this one, the not good PCB design. So as you guys can see, the wires were gone. Okay, so I don't know what happened with that image. So that is why you should you can also use export as PDF, or is PDF. We don't have PDF in here. All right. Okay, so the next thing that you need to do is print that one. Okay, next thing. The one thing that you really need to do, okay, not the next thing that you need to do. Okay, the one thing that you really need to do is this one. So where is that option? So I guess it's black solid. We have a monochrome in here. The one is colored. Mhm. I cannot find the black and white option. All right, Adobe PDF.
Still colored. Anyway, so supposedly you'll just export it or print it as a PDF so that you can generate a PDF file wherein it's only black and white or monochrome. But I cannot find it. The setup right here is colored. Okay, so I don't know how to change this one for now. So I will let you guys know once I uh, figure out how to change this one into a black and white color. So just click OK and then good design. I name this one good design. So just save it as a PDF and right here. So one thing that you guys will notice is whatever you have in here, it will be exported as a PDF. So to separate the top portion and then the bottom layer, so just go to layer, this one, oops, layer settings, right here, DB mini down button right here, and then just click preset, oops, just click preset top and preset top, there you go, so that you are only exporting the top portion layer, okay? So this is the top portion layer, so print and export it as a PDF, and then top layer, and save it as PDF, and next is the bottom layer. So preset bottom. Okay, so this is one thing that you need to check. So we only have three routes for bottom, and then the rest are ground. So let's click print and save it as a PDF again, and save it as a bottom. So there you go. With that, you now have the uh, two PDF file, the top portion, and then the bottom portion. So we have to print those two, okay, and then align them perfectly with each other so that the hole on the top layer is the same with the bottom layer. All right, so basically this is the one that you guys are going to print. Okay, so you need a special paper that I forget the name, but it's like a plastic, okay, plastic. So it will be print using a laser printer, and then that is the one that you're going to print on a blank PCB. This one right here. Okay, so before I mentioned the matrix, the one that has holes. So this is now the one that you're going to buy, okay, on the electronic shop. And yeah, this is where you're going to stick or paste that uh, printed PCB. And it should be something like this. Okay, and of course you need to clip the sides and for a, I forget the name, it is a chemical wherein you're going to put in there, wherein it will remove. Okay, it will remove the other covers, leaving you into what is the most similar, into this something like this. So the plastic PCB will be it's like you've transferred the printed area onto this PCB, okay, and then it will be something like this. And then you now start drilling the holes, okay, for the resistors, capacitors, for the connectors, etc., etc. And as a finished product, okay, so it would be something like this. Okay, so we already have the drill. I mean, yeah, the holes. Okay, it's already drilled. We have the silk screen. So we have the ground. Okay, and then some circle colors. Okay, and then the shape of other uh, components like this one, the resistors, and yeah, so it would be something like. And since you guys won't be able to experience this one, then yeah. So I hope that you guys find a way in the future to, try to experiment and then make a very simple PCB as a starter. And yeah, I guess that's the only thing that I wanted to mention for the finished product. And what else? Okay, so any questions so far? Question or any
None, sir.
clarifications? You guys sure? Okay, so all right. So the one thing that I want you guys to submit is the schematic layout and then the board layout. Okay, so just simply copy the folder Project Eagle. So you can find it on that specific folder of your Eagle CAD. So it's on resources. No, where is that being saved? So let me find my save projects. Where is that? Maybe it's 9.5. Maybe it's under documents and then Eagle. There you go. And then projects. So yeah, so this is the file that I need. Okay, the entire folder of that project. So in here we have Project Eagle. So just find that specific folder and then compress it as a RAR. Okay, and then that is the one that you guys are going to submit to me. So again, don't just copy the schematic layout, and then the board layout. So I need everything. Okay, so it might affect on how my application or my EagleCAD will read your project. So everything in this folder is important. All right. So are we clear with your final project? So let me just recall the things that you guys need to submit. All right. So in here, I am requiring you guys to have a black diagram of that project, okay, flow chart, a breadboard layout, okay, which can be done on a FreeSync, and a schematic diagram of it, okay. And then lastly, of course, the board layout. So I wasn't able to include the board layout in here. Anyway, so I'll edit it now so that you guys will remember that aside from the schematic diagram, board layout. Right? So this is one file, another file, another file, another file, another file. So I expect 5 files, okay, for your final project. All right. So are we clear with your final project?
Sir, sa breadboard
So again, we
layout.
don't have five. Ano yan?
Sir, sa breadboard layout picture.
Yes. No. So I also need the FreeSync layout. Okay, so let me highlight this one so that you guys can avoid copy pasting some images on the internet of your project. So you guys need to redo that one, okay, on the Fritz using the fixing fixing file of that. Oops, mali pinaglagyan ko. Should be on the breadboard here. That all right. Then of course, for the flowchart and block diagrams, it's just a picture. Okay, so yeah, you can save it as a PDF. All right. So any other concerns? Concerns or questions? So there's still one group who wasn't able to propose a project.
Sir, may sinambit na.
So I'll wait. All right. So I'll check it later on.
Yes, sir.
Okay. 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 Ano pa ba? Ano pa bang dapat yung alaman? Yeah, I guess that's it. So just in case you guys have a question in the future, so even though we're done with this subject, so let's say you wanted to create a PCB design. So if you want to chat me, if you want my help, you can chat me anytime. All right. Okay, so I guess that's it. If you guys don't have a question anymore, then you guys may now go and see you guys when we see each other again because this is already our last meeting. So good luck with your other exams since I know that you'll be able to finish this one as soon as possible since it's very easy. All right. So thank you too. So I really appreciate you guys to those who have come. All right. So thank you too. So goodbye and see you guys when we meet again.
Bye, sir.
Goodbye. Goodbye then.